can hear us. And we are good. Do you know how to hit record? It is already.
It's already recording.
Awesome. Now I get all this.
Okay.
Okay.
Ruby. Thank you. 1 o'clock, should we just like launch? Well, thank you all for coming. I see some familiar faces. So coordinated intro tutorial, OpenRVDAS and CORIOLIX. It's actually going to be somewhat segmented. I'm going to be spending the first hour mentioning CORIOLIX, but mostly talking about OpenRVDAS. Chris is going to take the second half, mentioning OpenRVDAS, but mostly talking about CORIOLIX. So if like you've already got OpenRVDAS down, you know, it's sunny out there. Now let's see. To gauge things, how many folks here don't have any coding Python programming experience? Okay. How many people here are comfortable with Python? Okay, cool. Don't worry, just I'm going to just drop some terms occasionally that
Hey, Pablo, you're muted for some reason.
There we go. I'm now unmuted, and hopefully I'm going to move this thing out from in front of where my stuff is. Maybe that'll work. Okay. So the way we like to think of things is kind of this nested series of functionality depending on how simple or how complete and all-encompassing the system you want to work with. At the very base are the OpenRVDAS loggers. Their job is to read, process, and distribute and store sensor data. On top of that, oh, come on, gotta click again. There's this thing called the OpenRVDAS Logger Manager, which reads configuration file. It acts the thing that actually runs the loggers. Owl, why do you have to be like that? Yeah. Okay. CORIOLIX lives on top and around that, and it runs Logger Manager, manages those configuration files, deals with metadata, coordinates real-time ship to shore information and the like. There are a bunch of chairs over here, folks. I showered this morning. It's cool. I can go over here too. Yeah. And so I want to be clear that CORIOLIX doesn't need OpenRVDAS to run. CORIOLIX can run on top of other systems. And there are lots of ships out there running OpenRVDAS with things other than CORIOLIX or with nothing on top. There are Owl. Right. The metaphor, the lousy metaphor that we've been dragging along for 3 years now is one of the metaphors we've been working with is if you've got to go out and if you've got a bunch of cows or cowboy stuff you need to do, think of this OpenRVDAS as the horse. It's like if you're happy to climb on the horse and you want to do things your way, you just install the horse. If you want a system that'll take care of it, you get the full horse. You hire the cowboy too. So it's not a great metaphor, but it's the best we've come up with. 2 t-shirts for anyone who comes up with a better metaphor. Okay. So you can have multiple cowboys. There are folks who are just using OpenRVDAS with Influx and other open source tools on top. But focus of this is going to be OpenRVDAS on the bottom, CORIOLIX organizing it. I, as advertised, I'm going to be talking about OpenRVDAS. I'm an engineer, so I have the outline. We're going to keep coming back to the outline. Let's talk about what actually OpenRVDAS is. So the term is, it is a part of a suite of open source tools for data acquisition. And Ocean Data Tools Collaboration, OpenRVDAS, OpenVDM, which is for a separate tool for vessel-wide data management, and C-Log is a modular platform for event logging. We're going to ignore OpenVDM and C-Log here because those weren't in the subject. So, at the core, OpenRVDAS isn't technically a data acquisition system. It's an architecture that allows you to snap together your individual, your own custom data acquisition system. The point being that each ship likes to do things a little bit differently, and designing a single monolithic data acquisition system was going to be a recipe for chaos. So the idea is, its main function is it gets the data from the sensors and to somewhere. It's data acquisition. And along the way, you can like process it, map it, display it, store it, filter it. At the core, it's made up of three types of components: readers, transforms, and writers. This was just kind of like, what if we structure it this way? These are these three functions. In the 10 years we've been doing this, I've been kind of astounded that there's been nothing we've been not able to do just by using existing modules or creating its own little, its own new little module. There are additional servers on the outside. That was the second kind of layer of the Matrushka I described. But the core of OpenRVDAS is just readers, transforms, and writers. So special about it, it's open. MIT license, anyone, all the code's out there. Anyone can use it, anyone can modify it. You can modify it and sell your own modified version. This MIT license, the most, I will say, permissive open source license out there. It's modular. So if you need some function, some transform, or if you need to a reader that will read from something that we don't have yet, you can just write up your own reader, suck it into the system, one extra line of code, and bang, it's there. You can use it. Similarly for writer, you want to write, you want to write to your own Coconut Telegraph writer. You code it up in Python, bang, one line, there it is. So together, what this lets you do is it lets you snap together your own data acquisition system fairly seamlessly with very little work. So basic idea, simple. Here's this dumb as day old toast logger, serial reader, timestamp transform, log file writer. Point it at a serial point, at serial port. It reads it, it adds a timestamp, it saves it to a log file. Right? That's the basic, that is the most basic thing that you can do with OpenRVDAS. You can create more. I'm going to see if I can get the useless laser pointer to. Caution, do not look into laser with remaining eye. Okay, so here's a slightly more complex logger. It reads from the serial port, timestamp, it transforms, throws it to the log file, but at the same time, it also parses that data, those data into structured data, sends them out onto the network, and also will fires it off to a time series database. It's a slightly more sophisticated logger. Other things you can do. Once you've parsed it, you can parse it, cross it out. As I said, here's a simple example of some structured data. You can display it, send it off ship or elsewhere. Some of the things you can do with transforms is you can numerically combine and process data from different loggers to produce derived data. Don't worry, all of this is all the introduction. We're just this is the trailer. So you can compute things like moving averages or true wind products. You can use those, you can process those derived data things to do things like geofencing. So, tell you, have you entered an EEZ? Yeah, so that's the high level of what we can do. It's one of the nice, or a benefit of that flexibility is it can be used in a lot of very different systems. like, so Seawolf down there center below is using it on the Windows box. It's just a single logger sucking stuff in on a laptop. Nina's got it fully integrated. Investigator, it has got a full OpenRVDAS installation. They've built their own front end. Actually, Kieran is Kieran in here? Kieran's got a demo of their front end set up at the back of the room. So it's running on, I've lost track of, dozens of ships in half a dozen different countries. Because it's open source, I don't actually know everyone who's running it. I got a query from the Chilean Navy last year about using it. So, okay. So that's the end of the trailer. Let's dive in. As I said, the basic core of OpenRVDAS is this logger, this thing that reads data, transforms, writes it. Think of it as a single Python process, a script. Okay. Now, to start using OpenRVDAS, all you need to do is just grab the repo from or grab a copy from the repo. Don't need, if you just want to run the individual loggers, you don't even need to run the install script. There's structure of the code for loggers is cryptically hidden in the logger subdirectory, and it has components: reader, transforms, writers, a thing called the listener we're going to talk about in a minute, and then utilities. So components: typical readers, serial reader, UDP reader, file reader, MQTT, log file, writers, database. Think of things you'd want to read from, think of things you'd like to write to. Those are fairly predictable. Gets interesting in the transform. There's some obvious things you'd want to do, like timestamp transform, prefix transform. You want to take this data string and give it a label that this, if you're sending it out on a common serial on a common UDP board, let folks know that this is the new send. You can parse, you can do, you can filter. Pretty much anything you can think of wanting to do to a line of data, you could create a transform. We've got a bunch of them already. So if you wanted to get down into the guts of it, and if you wanted like the fastest, most concise, smallest logger you could create. What do we have here? 7 lines of Python. This is a full logger. So you create a serial reader. You tell it where to read from. You create a transform. You create a log file writer. And you just loop through. You call the reader. What a reader does is it returns something to you. It says, here's an object. A transform, you handed an object, you handed a record, it does something to it, returns it. A writer, you hand it something and you handed a record and it does something. It doesn't actually have to write, it could just, but for convention. So if you really wanted to hard code things, this is fast and tight. Hello. There is, however, if you don't want to be writing code all of the time, there's this thing called the listener, which is a wraparound Python script that you can use to, you give it command line arguments, and it cobbles these things together and runs them. So here is a similar logger from the listener. Listen, serial reader, tell the port, timestamp transform, write the log file. Oh, this one also sends the records off to UDP. So you grab the code, you run that, you've got loggers going. Now, this is, remember I showed you like really simple loggers and how there can also be more complicated loggers. If you have a more complicated logger, you don't want to have to put all of that on the command line. So you can also create a configuration file. Say, run listen, run this config file. And the config file here, this is YAML. Does YAML strike confusion in anyone's parts? Stands for, okay, yet another markup language is what it stands for. And it's a format for creating structured data. Details aren't actually important at this point, but from here, you can sort of see that it has these 3 top level sections: readers, transforms, and writers. Under readers, says, here's one, it's a serial reader, the port, the baud rate, transform. This is a timestamp transform. Oh, we have two transforms here. The first is a timestamp transform. The second one is a prefixed transform, and we give it this argument that says the prefix that you should put on is Knud. So it'll timestamp this thing, then put KNUD at the beginning, and then it'll send it off on UDP. So records will show up with that prefix. I want to tempt fate by just pulling some live data, but hold off until we're a little more committed. There's one especially important transform, which is called the parse transform. And that's the one that takes raw data and turns it into structured data. Once you have structured data is where you can start having a lot of fun. So here's typical raw data coming from a GPS, from a CPAP 330 timestamped, and you put it through the parse transform, and it turns into fields like this is course, this is the GPS type, lat long, speed in knots, useful data that you might be wanting to pull some stuff off of. And there are a bunch of different ways you can instantiate a parse transform. One is you can really want a laser pointer. One is you can, when you call the parse transform, you can tell it, okay, the record format is I've got a data ID, a timestamp, the field string. These are what the fields look like, and then you create your parse transform that way, and then you call it, and you get your fields. Our gravimeter is actually a very simple thing. A CPAth is substantially more complicated. You don't want to have that near code. So what we will typically do is put those device definitions in a device definition file. Later on, when I talk about pain points, about things that are really ugly about running any of these systems, we're going to get back to what those device definition files look like. But here you create a parse transform that pointed to a file that has all of the devices that you care about. And then off you go. So the parse transform format is built on the Python parse module. There's another transform called the regex parse transform, which is based on regular expressions, right? Okay, so if you like regexes, again, these are just different modules. We started with the parse transform. The folks at Cyro said we like regexes, so they just put the regex. Bang, anyone can use it now. Okay, once you've got that, you can do all sorts of things, fun things. There's full documentation on the parsing circus online. And I mentioned earlier, if there isn't a module that you wanted, like you want to leave T-leaf, it was late. If instead of reading from a serial port, you wanted to read T-leaf, all you have to do is you create a Python class called, let's say, T-leaf reader, say what arguments it should have. It takes the T type and the temperature and you give it a method called read. And that. Then in order to use that in OpenRVDAS, this is your code. All we have to do to use an OpenRVDAS is in your configure file, say, use the T-leaf reader. Oh, this is where you find it. And these are the arguments you get. And so it's now bang, it's being used, it can be used by OpenRVDAS. And when your logger tries to read it, it's going to try to get data from it. It's going to call your read method. Seamless. Okay, so if you just want to create individual loggers and run them, that's all you need to know. It's a really basic, straightforward system. This is my favorite. I can't prove that this is the smallest OpenRVDAS installation out there, but this hangs off of the USB port from a power socket outside my home. It's a Pi 0 and a BME 688, and it's measuring barometric pressure and humidity and volatile air compounds and other stuff. There's actually, I'm cheating. There are two of these. There's one outside and one inside. So I have indoor humidity, outdoor humidity, and fluid stoke temperature. But this is a Pi 0 running OpenRVDAS. Now, so as I said, if this is all you're after, great. no, I'm giving a talk now. If you want to have more loggers, if you need them to change states, if you want monitoring, you probably actually want to do the full OpenRVDAS installation. And that's really complicated. You do what we did before here, and then you run the install script. And it's going to ask you questions like, what do you want your machine to be like? Do you want to set up secure sockets? Do you want to run the simulator? Do you want this stuff to run on boot up? And then it'll install things and say, happy logging. And you will be left with something like, I'm not going to go there yet. So mostly the rest of that stuff it's doing is it's firing up and configuring the servers that are going to keep OpenRVDAS running. And the servers are non-intuitively in a directory called. Thank you. I know it's after lunch. So here's a cartoon diagram of the server architecture. There is this thing called the logger manager, which is the thing that manages the loggers. And it basically, it checks that they're running. And if they're not running, then it tries to get them running. And it reports the status back. How does it figure out what should be running and what shouldn't be running? Well, there is a database running. By default, it's a little SQLite thing. And so it reads the database, figure out what should be running, and it writes back into the database what's actually happening. Well, how do you? There's a web front end that writes to the database, tells you what should be going on. Feels a little complicated. There's a really good reason. So one of the big things is, is that there's another slide before I tell you what one of the big things is. Behind the scenes, what's going on in a normal default installation is there's a Linux folks supervisor daemon. Basically, the installation script sets up the supervisor daemon to run the logger manager, a thing called the cache data server. We're going to talk about that in a little while. And then the front end and interface. So what this gets you a web interface for controlling. That's that top thing that on the diagram. So you can see what the status of your different loggers are. You can change them. You can start and stop things. It gives you cruise mode management. What this means is you've got all of these loggers, right? And another slide on the, yes, okay. So when your ship is in port, when your ship is turned off, you want everything, you don't want any of the loggers running. When the ship is in port, it's still like your bridge display to show like, what's the temperature, what's the GPS. You'd like some of these instruments just to be feeding the bridge, right? Your sonar isn't going to be on. You don't. So you want your Knudsen to be off. Okay. Let's say you're cruising out. You're at sea now, but if you're with the Antarctic program, you're going through the Argentine waters on the way to Antarctica. Well, we're not legally allowed to actually store that data. So we're running all of this thing. We're running the Knudsen because, if there's something, if we're suddenly in shallow water, we'd like to know that, but we're not. So we're sending this off to the network, but we're not actually saving it. Once we're underway, we're sending things off to the network and we're saving it to file. So rather than turning all of these things off and on individually, what we'd really like to be able to say is like, okay, bang, we're underway now. And all of the loggers start doing that particular loggy thing. And then when we get back to EEZ, we say, bang, we're in the EEZ. And it basically marshals them all together. So those are cruise modes. Logger Manager lets you manage cruise modes. And the final thing is you get this database-backed state management. So if things crash, comes up, it knows where it was, it's running. Also, in addition to having that front end, somebody else on another machine, authorized, can also control it. Or if they and let's see, so basically you can control it if you are on the network and have authorization. You don't have to be at the physical console to run this thing. There are a bunch of different ways, as I showed you. There's a default a web interface. If you're old school, you can also fire up the command line interface. And the whole thing is that database has a RESTful API. So if you don't like either of those, you can put together your own interface. These are a few interfaces that were created by the Kiwis at NIWA, National Institute for Water and Atmosphere. Everything. Louis Wilkie wrote these up, and Kieran from Cyro is, as it's at the back of the room, in the big room, is demoing his own really cool GUI that I wish I had come up with, where you can like you have logger groups and you can collapse them and slide them around. It's very sexy. But the point is that the why would we do everything through this database? That's why, so that all you have to do is talk to that database via the API, and you can have whatever front end you like. Okay. There's one non-intuitive little server in there called the cache data server, and it's a little bit of a hack. And basically, when I say pub sub server, raise your hand if that puzzles you. Cool. Okay. So a pub sub server is, think of it as a temporary storage system. You can say, you can send it data, and it'll say, okay, I got it. And then somebody else can ask for that data. So you can publish the data to the server, and you can subscribe to data from the server. So for example, my GPS here, this is F330 data. I'm just going to send my F330 data to this cache data server, and any other system that wants to get data from the F330 can subscribe to it. So when another line of GPS data shows up in the cache data server, these other systems that want it will get notified and will get the data. Why is this useful? The bane of every logging system, true wins. Okay, true wins. Yeah. Which sensor does you get true wins from? You need to combine the data from 3 different sensors, right? Your compass gives you heading, your GPS gives you course and speed over ground, and then your MET sensor gives you relative wind speed. What do? Well, you have each of your loggers. You have your GPS. In addition to sending you have your GPS logger send its data to the cache data server. You have the compass send its data to the cache data server, and then you create. Okay, so there we go. You're going to have the diagram. So these instruments send the data to the cache data server, and then you have a thing called a true winds logger. And rather than reading from a raw sensor, it reads from the cache data server. It computes the true winds, and then as a bonus, it takes its output back to the cache data server. So basically, what your true wind logger looks like is you have a cache data reader, followed by true winds transform, followed by a cache data writer. And that is, let's see, do I have tempt fate? Sure, why not? Nah, we'll get to it later. Okay, so I think this is a recapitulation. So another thing you can do with this is you can smooth data. You know, some folks want, for example, I don't remember who did this for. I can pretend it was Ocean X. They want every 5 minutes a single average value for all of the sensors. And so we want a snapshot averaged over the last 5 minutes, bell curve. So what you do is you have a cache data reader that asks for all of your data, and interpolation transform, send it to a cache data writer. And then you can take messy data like that and get nice smooth snapshot of those. Another thing that's handy with the cache data writer, I'd mentioned geofencing before. You know, when we're inside Argentine waters, we can't record data. Once we leave Argentine waters and our international waters, we can. With the NBP, that usually happens at about 3 in the morning. And so historically, what has happened is one of the sysadmins, even if there's no science going on, like has to be up and it's like watching the GPS. They ran. Okay, start it. And then coming back, it's like, okay, now we're out. Stop it. Oh, but we need a little bit of a buffer. So we have a thing called a geofence transform. This is like for like 2 or 3 years, we said, you really ought to be able to do that inside of an RVTEC, right? Like, how hard would it be? And so it's actually pretty straightforward. So the geofence transform is something that reads, it reads from the cache data server, and it looks for 2 fields, a latitude and a longitude. So here we're telling it, this is where you look for the latitude field, this is where you look for the longitude field. Here is a boundary file. Now, what this transform is going to do is it's going to just keep getting GPS records, and it's going to transform them most of the time into a null record. It's not going to output anything. It's just going to output none, 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 none. But this thing has a bit of a memory, and it'll get a when it gets something, it'll check: is this inside the EEZ? Is this inside the shapefile? It's like, yep, nope. Ooh, it's not inside the EEZ. Was the previous one inside the EEZ? Then it'll say, okay, we've transitioned. And what it will do is, part of the definition is you say, when you've transitioned, when you've leaving the boundary, output this, which says set active mode right. When entering the boundary, set active mode no right. So we basically told it where to look for the data, what shape to look for, and when you go from inside to outside, output this. When you go from outside to inside, output this. Okay. So this is basically, will only give us a signal when we flip one way or the other. What do we do with this? We feed it into another little module called the logger manager writer. And what that does is that takes whatever data it gets and feeds it as a command to the logger manager. Okay. How dangerous could that be, right? Right. Fortunately, one of the parameters is, what commands are you allowed? And this one, here we say the only commands we're allowed are things that begin with set active mode. So geofence transform to a logger manager writer. When we leave the EEZ, it'll say set active mode to write. Logger manager writer will go, oh, I know how to set active mode to write. It'll start writing. When we enter the EEZ, we'll go back into no write. So basically, the system is used by with this transform and this writer system is turned on itself. Technically, I think it's now Turing complete, right? We can do any computation using transforms writers, but there's in addition to this sort of working inside of itself, just recently, brand new readers and writers is a C-log writer and a C-log reader. So C-log is an external open source event logging system. And so you can have, with the geofence transform, you can have a C-log writer say, log the event. We left the EEZ at this time, at this location. Similarly, you can have some external event trigger a change in OpenRVDAS. We've just begun to explore, we just got those integrated 2 months ago, and we just begun to explore kind of the crazy things you might be able to do with that. Where are we next? Okay. Beyond OpenRVDAS, that's sort of the core of what you do in OpenRVDAS. Beyond that is the question of, we've acquired the data, now what do we do with it? First thing we want to do is get it out of OpenRVDAS so we can put it in a log file. So, we can send it out over the network, we can send it to the cache data writer, send it to Influx, Timescale DB, Redis, Postgres, CORIOLIX. These are all writers you can send the data to, and you too can run your very own writer. Another thing you can you can do is rather than storing it is for displaying it, right? So originally, when we started OpenRVDAS, we were trying to write our own displays. It's still in the original code, and you can still get to it. Let me see. So it's under the displays, directory, and this is based on high charts, but this is code. This is widgets in OpenRVDAS that you can embed in any web page. This is running on simulated data. We're using the smoother. We're using the true winds calculation. It's just kind of a shiny demo. And then we go back to here. What we realized pretty quickly is us maintaining our own graphics and display library. Stupid. There are existing database and graphics libraries. Influx, so Influx is a time series database, similar to timescale DB. And Grafana is at the same organization, is an open source analytics visual monitoring system. Each of these guys has, I kid you not, tens of millions of users. They've got displays dialed in really nicely. We want to get out of the display game. So nowadays we recommend that you use either your timescale DB or Influx DB. Use Grafana for your displays. Nice thing about Grafana being open source and Influx is you can create your own modules for that. WebPinner, my co-conspirator, it was Lewis Wilkie, wrote a cache data reader for Grafana displays. So for really high rate stuff like winch data where you don't want to have to write to the database, read to the rate database, you can have Grafana read directly from a cache data server. Okay. Getting OpenRVDAS to work with Influx and Grafana, it's really complicated. You run the install script. In order to actually get the data to Influx, who is it? There's an app for that. There's a writer for that. This Influx DB writer. You basically, tell it what's the URL of the Influx instance you want. You give it what the bucket you want to write to. In the configuration, you need to have the auth keys, but so that can be here. You don't want your auth keys in a config file though, so that's on disk. Grafana widgets can be pretty darn cool. This is, let's see, do I have this live here? This is a Spanish ship, the Sarmiento, and boom. So this is live Grafana data from the Sarmiento. Where are they? It's Mediterranean ICOM. And I don't recall whether they're using Influx underneath here, but in any case, that's just more. Oh yes. Other bits about Grafana, yes. So we aggregated these. Said you can roll your own and contribute widgets. WebPinner just created this combined true and apparent wins plus course widget. Is this? I don't remember what this is. Click on unknown links. Yeah, maybe not. We'll get back to that. Other things you can use Influx and Grafana for is you can use it for QC. Web has created a logger monitoring dashboard like that. I'm wondering if I'm on the wrong network. I should be able to get to this. Maybe I can't. That's okay. So basically, you can see what's up, what's down, and how long it's been up, down. Let me actually pop out, and I feel like I ought to be able to get to. Okay. This is just sample, this is running sample data from the NBP from, wow, 11 years ago. And so I'm going to do just a bit of demo-y bits. So we've got all of our loggers here. This is sort of the recent standard out, and you can see you get a yellow. We can expand that to get more data. This is the status of the logger, what's been going on. We can turn these loggers on and off. Actually, we have to be logged in. Let's go. Log. Okay, we're back. Now we're going to turn off the ADCP logging. So it has these different modes here: off, on, FileNet. So just turn that off. Update that. And let's so is that dashboard I showed you earlier here. The dashboard is running behind going back here. So we're going to change all of the log. I'm going to just turn all of the loggers off right now. Behold, and while we're doing that, loggers are all going off. And the displays stop updating. Okay. I've demonstrated my power over the simulation. Okay. To start stuff up, the background, that's a demo server. Let me know if you want to mess with the demo server. It's out there. Those of you who are watching, it's completely unguessable password. As you know, the username is RVTEC, and the password is 5 letters. Okay, so that's sort of the what OpenRVDAS can do. Now, sort of actually what you actually have to do in order to get OpenRVDAS working. And there's creating those cruise configuration files. There's creating the device definition files. And then there is the monitoring and keeping everything updated as it changes. So setting up the cruise configuration file, this is where the pain starts. Because I showed you that that logger or the demo page for the NBP, each one of those little green boxes was a logger. Each of those loggers has a bunch of different configurations. Like, so the CPath, when you're writing to the file in the network, you've got your reader, transforms writers, etc. It needs a different configuration for when you're just writing to the network and not a file. It needs a different configuration when you're not doing anything. Okay, so you need one of those for each of the loggers you've got. Okay, you have to then define what loggers do you have. Your CPath, you say your CPath has these 3 configurations. Your Knudsen has these 3 configurations, etc. And then for each of that, you have to define the modes for each of them. Now, each of these, this is nice and small. It fits on a single page. The original configuration file for the NBP that we looked at was over 1,500 lines. Now, let's say you want to do something slightly different. You want to edit that file. It's fraught. The folks at Styro, is that somebody raising their hand every time there's a ding?
Oh, come on.
Okay. Or going out by. So Ella down at Cyro, smartest systems thinkers I've ever met. They came up with this model for templating, took our 1,500 line configuration file down to about 200 lines. And so nowadays we're basically recommending that everybody just uses Ella's template. And that's the current documentation. When you go to openrvdas.org and look at the docs, it'll tell you how to use the templates. But still, that's manual. The next thing that we don't have a good solution for is the device definitions. Now, we've seen this slide before. of, where you tell, you tell the parser how to parse things. And in the OpenRVDAS system, the two ways you can do it is you can either give the complete device definition on that line where you have the parser, or you can put a device definition file. And device definitional files are still a little convoluted because there are these two different things. There is a device type, let's say a CPAP 330, which is any CPAP 330, and then there's a specific instance of this the CPAP 330 that's on your chip. And on the NDP, we have two TSPs that are they're the same type of box, but they're two different instruments. So what you have to do is first you define device type, your gravimeter. You say gravimeter BGM3 is a device type. This is the format of this that this thing puts out. These are what these values are called. And then you define the individual devices on your boat. So gravimeter 1, GRV1 is a gravimeter BGM3. And when it produces a value called gravity value, you call it grav1 value. And basically you have to create this library of device type definitions and the devices on your ship. And again, that's something in OpenRVDAS you have to manually manage. All of it's documented at openrvdas.org, but the details are a bit messy. One of the inspirations for CORIOLIX was to help reduce the pain of that. And Chris is going to be talking about how all of that wraps around and manages. I'm going to best practices. Actually, actually the timing is about right. There are on the site, there's a ton of stuff about the best practices. We're not going to talk about them here, just because I want there to be time for discussion. Contributing. This is the obligatory. It says bug reports if you're using OpenRVDAS. File issues, new code contributions. Something I didn't put on here is we have a Discord. Most of the community, we like communicating with folks via the Discord. Ping me, I'll get you a link to it. It's a fairly active discussion. Request features, ask questions. Where to from here? Two big things. One is you can never have enough documentation. I'm sort of documentation obsessed, but let's go to, come on. Don't want to stop sharing. Let's go to some other window here. Oh, the inbox. You don't want to see my inbox. Go OpenRVDAS. So this is kind of, there's a bunch of getting started stuff, guides, links through. There's a cookbook of some basic things like adding sensors, getting geofencing working, extras, what are extras? Oh, an old version of this talk. And then the reference of other things. So let's go back here. But we get a lot of the same questions over and over. So clearly they're talking. Another big thing that we're working on is figuring out a long-term support system for this project. So I was just realizing it was 9 years ago that Valerie Warner and I first stood up here and said, hey, we've just been sailing on the NDP and we put together this cool bit of Python for gathering data. It's like instead of 5,000 lines of Python per logger, it's like 20. And we think it's kind of cool. And we got absolutely mobbed by people saying, can we use your code? Oh, you think? Okay. So that was 9 years ago. And since then, OpenRVDAS has been primarily funded as a volunteer operation. I was telling somebody here that, I wear many hats. And over the past 2 years, I have earned more money as a traveling singer-songwriter, folk musician than I have doing OpenRVDAS coding and support. And if you imagine how much money a random middle-aged guy doing singer-songwriter stuff would make. Yeah, so we're basically still primarily volunteer funded. We get some contracts here and there. I do an awful lot of volunteer work. Jules, I should have brought it as Jules gave me a mug that said "Low Code for Ship Time." So we're working on that. We're having some useful conversations about longer term funding sources. Of course, recent recent events have made that more complicated. But that's pretty much these are our two big questions right now. What else do we have? I think that's the end of the deck. Pretty much. I'm going to declare it's the end of the deck because this is frozen. We have 10 minutes before the break, or we could take a break early and Chris could kick in 10 minutes early then, and Chris and Kristen, sorry. And then we could have more time. Then we could have questions when both systems have been talked about. You've got like a full stack view. Okay. Oh, one last thing. I like questions, and for those who ask the best questions, there are a limited edition of stylish Ocean Data Tools OpenRVDAS features available, even if the question is about CORIOLIX. So,
Anybody wants one? Well,
yeah, pretty much. Well, it's all colors. So we take a break. Let's meet back here at 2:02. I've got 1:52, so 10-minute break. Well, how long is the break supposed to be? 15 minutes, okay. I can do math. 107. 207. I can't do math.
It's 2:08 now. It's 2:08.
Okay, 208. Break. Thank you.
Very good.
Don't take that minute.
Even though I was really-
Chris, do you want to switch over thing?
and I'll probably start that early, right? I'm gonna go grab my external.
Yeah, I was in your talk. Yeah.
We spoke on the phone.
Oh, good. I'm so pleased.
T-shirt.
Oh, thank you.
Yeah, and I did it. That's him.
Sure, well, Thank you. Thank you for diving in.
Okay.
Thank you, by the way, for your. No, that was great. No,
But there's a
$8 billion brand.
line.
And 8 billion data points each.
I'm gonna get those folks online. So,
External view.
participants online participants. Sure. Pretty good. Our team over here.
So what happens?
Back and break.
Yeah.
Because there was ice
We
cream.
don't want.
So you're gonna give it an extra 10 minutes. I'm gonna start next.
And Peter says, well.
Yeah.
It's yours.
Everything going okay?
Oh, yeah. So they can't figure out how to back through.
I tried to convince him to join.
I need to go backward. Oh, there we go. I was dead for a minute.
I didn't
Understand.
I was trying.
It's still good,
And he did. He did eventually.
It's open, are there
Yeah.
monitoring for pressure. So
Oh, thank you.
it's posted.
Thank you.
And it's recorded.
This Bible,
So-
that's what I said.
Yeah,
Cool.
yeah, he's really good. No, this
It's
was
a little flaky if I touch
Actually, I
the
think this may have
dongle
been
video.
the
So
original.
I'm try really hard. But
Because
video.
I was teaching it 2 hours on the team. We have like
Oh,
200
okay.
engineers and the folks from Bangalore.
I'm such a like touch
And eventually.
Yeah.
advances.
We actually videotaped.
Okay.
Well, not
Walk.
Gentle.
And, any case.
Very much like MIT frameworks, that we used to do like.
Oh, maybe I'll just make an announcement outside.
Oh, yeah.
Video learning.
Rabbits.
Needs.
Nope, nope, I'm gonna sit over here, so it's less intimidating.
You want my seat, Bible?
Nope, nope, no, I'm good. I'm gonna grab this one.
I think that's, I look like everybody out there. Most of them. Yeah, we have
Everybody who matters.
I counted, we had 30 people in the first session. It looks like we have roughly the same group, so. That's cool. All right, audio is on, video is on, screen sharing. I'm Chris Romsos. I am gonna lead the second part of this, what are we calling this, a breakout session 2. So I represent the, the CORIOLIX project, but it's not just me. There's 3 of us, and I'll tell you who they are on the second slide. But before we do that, just like Pablo, let's take a minute. Pablo just gave us a really nice explanation of how OpenRVDAS works and what you can do with it. One of the reasons we wanted to do this joint breakout session is because oftentimes people hear OpenRVDAS and CORIOLIX, and they, for whatever reason, kind of conflate them as the same, doing the same job, and I don't think that's actually right. So we want to kind of disambiguate what the 2 systems are. So hopefully the way we structured this will kind of make it all clear. So we're going to go over just a little bit of review, what it is, what it does, why do we need it, how does it work. But I'm going to try, I picked out 2 examples where we integrate with OpenRVDAS, and I'm going to try to use those to further reveal how the systems work together. And I think we're going to have a good amount of time for questions, but I talk a lot, so we'll see. Okay, so now it doesn't advance, but maybe I just need to click it. There we go. That's me. For those of you that were here yesterday, already had a bunch of stage time. Good to see you all again. But I want you to know about Jasmine and Tristan. These are kind of like, Jasmine and Tristan are the heart and soul of CORIOLIX to make everything happen. Tristan is new on, well, he's been here a year actually, so it's a full year. I think he didn't go to RVTEC last year, but had come on at the end of August. Tristan has been our, well, we intended to be our interface to NOAA. We're starting to work with NOAA, but has actually had quite a bit of work to do on some academic research fleets projects. So he's involved with both. And I think most of you, if you know about CORIOLIX, know Jasmine. She's kind of our lead developer, responsible for the look and feel of the website, takes a lot of your support calls and works with end users to try to improve the system, and she does a really good job at it. Okay, that's who we are. I liked Pablo's slide. I've borrowed, the look and feel. And he had this cool slide of CORIOLIX installation or OpenRVDAS installations. And so I thought, okay, this, it's good for you guys to know we're a funded, specialized service for the fleet, right? And it's our objective to bring on 1 to 2 boats a year and to grow our participation, but it's completely voluntary. These are some of the boats that we are currently working with. We're on the Point Sur and Kuliak in Savannah, fully deployed and operational. We're working on getting there with Roger Ravel. We've been working a lot for the past maybe 6 months. That's a work in progress, but we do have a ship side and a shore side server set up. We're just kind of working with scripts now to carefully bring different sensors into CORIOLIX and make sure that's all done right. So Pablo explained to you how seamless and easy it is to download and get started with OpenRVDAS. I would say it takes a little bit longer. Really, when you come over into the CORIOLIX world, we're going to really get into your metadata of your system, right? Because that's what's going to make this all work. So next up for us, like immediately, is to start working on the Shimada and the Pelican. And I should mention that we had 2 additional boats, but this is kind of the sad bullet point, the Oceanus at OSU and the Endeavor did run CORIOLIX. They were kind of those were our first 2 test platforms. And Bonnie just sent me back the CORIOLIX server and I just got it last week. Maybe we'll be able to put it back into service on another ship or something. It's that easy. Okay, so what is CORIOLIX? Pablo had a really nice kind of one line. And we already talked about the horse and cowboy analogy or metaphor. So Pablo, OpenRVDAS, part of a suite of open source tools for data acquisition and management. Pretty straightforward. I would say CORIOLIX builds on that. I'm going to move whatever this little widget overlay is. The most concise definition I could come up with for CORIOLIX is it's a distributed software system, connects shipboard and shoreside nodes for the purpose of live situational awareness. That can mean a lot of things. So maybe expanding on that, one-liner, CORIOLIX is designed around real-time or near real-time mission support. So not just logging the data, but visualizing the data, being able to set up notifications or alert and actually facilitate the remote support and monitoring, right? We bridge the ship to shore in a unified way. We have the same web interface in both places, which really helps, the conversation and you're having support. You're looking at you're working in the same environment in both places. We move real-time observational data to shore where, and we can move data products from shore to ship. We can talk about that in a little bit. But it's really built with your operation in mind, monitoring sensor health, creating histories for how your sensor has been maintained, or even how it's been configured within the system. Like I said, alerting. So we're adding on scope, I guess, to in the system, and we're acknowledging a little bit larger user base, I think, in CORIOLIX. Let me click here again. We're getting a couple new arrivals, so I'm going to slow down a moment. Let them get a seat. I did a quick feature comparison. We don't need to spend a lot of time on this, but we've already gone over the primary function, I would say, for OpenRVDAS is to collect and log your sensor data. CORIOLIX would be to display it, monitor it, synchronize it between ship and shore. This is where I was trying to make the argument that I think CORIOLIX of users to be more than just your technicians. The pipelines are Pablo described a really nice modular system with management on top of it. We take that, we add our own web application to interact with OpenRVDAS. Like I mentioned at the beginning, setup and maintenance. Pablo kind of showed you really quick. Deploy the repo. To deploy CORIOLIX takes a kind of coordinated effort because I'm going to work with you to create metadata records that you probably don't have yet in that way. So it's a more together process. Where OpenRVDAS is reading directly from your sensors, CORIOLIX is managing where that goes, how that gets read, but it's really accessing data once it's written into the database. So, we already kind of talked about real-time visualizations with OpenRVDAS, very much enables you to build really cool dashboards and Grafana. We take that responsibility, not that we want to redo that and take that all those degrees of freedom away from you. It's just that we kind of developed a base set of visualizations to get you going. It doesn't preclude you from, in fact, on Seculiac, Julian has a bunch of Grafana dashboards that do just what he wants to see. Maybe it's something diagnostic and you can just plug right into the database or the API and do that. But we give you out of the box, a default visualization environment that is designed to work within the system, if that makes sense. And so that takes an argument I'm trying to make carefully is that takes work off your plate later on. Ship to shore. I know that many people ship to shore synchronize their OpenRVDAS data with OpenVDM. It's a great way to do things. We have a native data synchronization kind of built into our system because it is a distributed system. Okay, so enough about the comparison. I feel like I didn't do. I think I skipped over this, and maybe I'll just do it anyway because I forgot about it. I said a couple of things that maybe you're like a little jargony. Distributed, and this is kind of key, distributed software system. It's a collection of computing systems in different locations, right, that are working together for this common goal of managing your data, moving it to shore, providing it to your users in the same way. Nodes. So the nodes that, that notion of nodes are those independent installations. And situational awareness, it's just an easy way to say anything from, I want to take an action based on something I'm observing here, in real time, to maybe it's, somebody on the beach that has an alert that, there's certain conditions that are met and they can, start their analysis. It's meant to mean a wide array of things. Okay, so I skipped that accident. Okay. What does it do? It manages CORIOLIX manages your logging configuration and your logging state across the full system. And so for an RCRV, it's a pretty, there's actually like an extra layer of nodes. We have remote OpenRVDAS installations that we communicate with because we have sensors in different parts of the ship, right? So maybe we run sensors into one OpenRVDAS. We can configure that and have it send it to a central one. Most people don't run like that, but what CORIOLIX is going to do is, in the minimal sense with OpenRVDAS, is it's going to build for you based on your metadata that you maintain inside the system. It's going to build that logging configuration that Paulo was talking about. We call it the cruise.yaml file. Very excited to hear that another research team has taken has templated that and made it less verbose. So Pablo showed you a configuration file of about 1,500 lines for the Palmer. If you start adding lots of different modes in there, kind of like we have many different modes of operation, that could balloon to 4,000 lines. And so CORIOLIX, you'll never see that. It'll build that for you. It'll push that out to OpenRVDAS and put it in place. So that's kind of like a very big value add, I guess. CORIOLIX also does data processing. we do some data processing using OpenRVDAS in real time. And then we also do delayed data processing to reduce a couple of things we do. We reduce the data through a binning process to once a minute by default, or one value per minute. A lot of, you know, there's a lot of utility for that data set. I'm not saying it's science great. Yeah, I think you understand what I'm trying to say. You can set a default, or I'm sorry, a custom bin interval. So we do a default, we allow you to do a custom. So there are binning processes running behind the scenes, looking at, you know, delayed, kind of running on delay. We can do flagging in real time. We can do delayed flagging using those same processes. I'm going to show you one in a minute. CORIOLIX annotates your data. And what I mean by that, I think the most direct thing would be the flagging. You know, an annotation would be, well, actually, you receive a record from your instrument. Pablo showed us that, you know, one of the things that you can do in OpenRVDAS, and we do this CORIOLIX, is put a timestamp on it immediately. That's an annotation. Put a sensor identifier on it. That's an annotation. Then there's your message, and then maybe we might parse it, transform it, we might evaluate it, we might put flags on it. Another annotation, right? There's another, you can think of annotation as creating a sensor log. Anytime one of your technicians is working in CORIOLIX and makes a change, that change is logged, and it's logged by who made the change, right? So you have a running history of like what went on. Might be very useful. It performs data replication between the ship and the shore. And there's two things we'll talk about a little bit in a minute. I have like a diagram to show you this. And it also it has a lot to offer, I would argue, for data access. There's many modes to access the data. We save data in the file type, right? So you can always access the data that was received by our OpenRVDAS before anything was done to it as a file. You can download data from the CORIOLIX interface as a file after it's been processed, right? So we've got the raw, we've got the processed. You can there's many different download formats available. We leverage something called the RDAP data server behind the scenes, which gives us those data transformations, CSV, OpenDAP, stuff like that. Like I mentioned before, there's a time series database on the back that's feeding data visualization that we have built in. But it's got an API if you would like to build your own dashboard, you could do that. And we're going to do that for RCRV. We have a use case where we would like, you know, within our KVM system and within some displays to do some things that really are kind of out of the box for CORIOLIX. So we'll actually be leveraging Grafana stuff also. So it's kind of like, it really depends on what you're trying to do, right? What we're doing with CORIOLIX is trying to acknowledge remote participants onshore that want to engage with your scientific activity, might want data feed, might not. Maybe your shoreside participant is other people in your technical support office who are updating metadata for you. A new instrument came in, you know, they enter it into CORIOLIX, the data syncs, you know, that takes pressure off somebody on the boat where your only instance of your system is to do that, right? I'm sure you can imagine there are many benefits of that. Okay, so that's what it does. I don't have time to show you all of that. What I'm here to do today is show you how it works with OpenRVDAS. So we're going to talk about data acquisition, data processing a little bit. I will say, made all these claims to what CORIOLIX does. Do we do that all on our own? Absolutely not. There's no reason for us to write our own data acquisitions modular thing like OpenRVDAS because it does it so well, and it's very easy to implement, like inside of our environment. So we found, you know, is our preferred data acquisition system. Pablo mentioned that we also work with other data acquisition systems. We started working with SCS. I mentioned that we were on the Endeavor and the Oceanus first. That's what Endeavor and Oceanus were running. And so we kind of cut our teeth on SCS, but have really been moving away from SCS even in our NOAA work. Scientific data server, underneath the hood is something that we are borrowing from NOAA. It's an RDAP data server. It gives us, connects to our database. It reads all that information in our database, and it gives us data transformations. It puts out open geospatial web services. Really cool. We're using a Postgres, basically an enterprise database, but in the FOSS world. We use symmetric DS for database replication, Leaflet for our mapping, and we used to have pie charts for all of our charting, and we've recently, Tristan did all this, redid everything in Apache eCharts. So the charts actually perform a lot better. Okay, but that's the next version. So again, I can't show you all those. We can take questions on any of them. I'm going to focus on the data acquisition. This was my swing. That's a different metaphor. The cowboy and the horse just doesn't feel great. So I was thinking about the Venn diagram, and it's like, okay, if we had to do everything, that's a circle, but OpenRVDAS can do our data acquisition, so we're going to cut it. That's a donut, got a hole in it, but then maybe it's a jelly donut. So that's what I came up with: flavor, data and flavor, and ChatGPT made me really sure. Together, end-to-end visibility from sensors to shore. It was late. Pablo said. Okay, can somebody give me a time check of how long have I filmed?
29.
29. All right, we've got. I could do this one of two ways. I could do it live, or I could walk through it. I think it's probably just easier to walk through these slides. Has everybody seen the CORIOLIX interface? This web page? Does this look unfamiliar to you? Okay, 2 or 3 people. We'll pull up the interface and go a little bit more live then, probably in the question session. It's a web, it's like any other website, lots of navigation across the top. The things to know about it are anybody can access the site, right? You don't need a username or a password to visualize or download data at this point. If there's a situation that calls for it, you can do that. So you can, with public access, you can take a look at data, you can download some data, you can view sensor metadata, and you can't view event logs. I believe that's a mistake that I made. You have, you can get into it, but you have limits. There's limits to what you can do. If you sign up as a user, create an account rather, up in the My Account, there's a little thing, create an account. Somebody with administrative privileges can then grant you another level higher. So on Endeavor, Bonnie is our CORIOLIX person, and she's got full admin privilege on that, I think. It's not really, we call it technician privilege. Jasmine, Tristan, and I have the administrator levels, another level higher, things that we can do. But what I'm trying to say is that, okay, so the people that have things to do inside the system, change configurations, swap sensors in and out, reconfigure a log, or are doing that, as themselves, right? As an identity, and that's important so we can kind of go back. And they're specifically granted that privilege to do that. If you create a user, public access you can view, you don't need to create a user, but if you do and just stay public, then you can do things like create an alert. So that's kind of what we think scientists are going to want to come in, create an account, and get that, then we're going to be able to track what they want to know about and maybe make an alert to send them data or something like that. That will then allow them to see, create events in the event log for their crews. So I kind of conflated 2 types of public in that first block there that it shouldn't have. Then there's that, should read my slide. It's the second one, pardon me. The technician access is the third one. It's funny, you're only 10 feet away from it, but you're not reading it. the take home message is, there's these different levels. And that's kind of what people can do. The first page we like to take people as at least technicians is kind of, what's the status of my system? You go here, you can quickly know anything in red might potentially have a problem. You could mouse over it and they'll give you a little blurb about what the actual problem is. These sensors are just happen to be off. December 2nd we're still sailing, we're here.
I mean, it's just to figure out flow through off. So.
Yeah, your flow through is off, maybe an import. So status page, you can drill down to deeper levels. And like if you clicked on one of these red things, you go to that page, right? There's the big thing behind the scenes to know is there's an inventory of every instrument that you have that you want to collect data with inside of CORIOLIX. So all your underway instrumentation, maybe some visiting science instrumentation, you want to log it, it goes in your sensor list. And then there's many different attributes for a sensor that we collect, from serial number down to the documentation that is provided to you. So we have links to all the PDFs. You put your calibration files in there. If the calibration file is like digital file, we can parse it, and then it's not, that you can put your calibration coefficients in, and we're going to actually use that data when we build OpenRVDAS loggers, and that's where I'm trying to get to. Parameter, every sensor has parameters, right? You bought a sensor from Seabird and it measures X, Y, and Z, T, S, and G. So we have a inventory of parameters that are any given parameter is associated with a specific sensor. So very much like I think Pablo was describing with device type. We don't use those device types. This is an example of evolution, and I don't know, I'm not a biologist, but we're evolving in parallel. We got out, I think, kind of came up with our own way of managing this, and Pablo, as this notion of device files has come to be. We don't stay in our lane. If it's a good idea, we're going to incorporate that. If we can save lines in our config files, we're going to do that. I was thinking if maybe there's things in the cache data reader that were like Pablo, I was learning things in that meeting is what I'm trying to say, like got ideas for improvements between synergy, kind of synergistic things here. I'm not going to go into how, all the different things we collect about this, but this is when I mentioned that it takes a little spin up, it takes some time. These are the things that our team works with your team, if you're a user, and gets all this stuff right. Like we're funded to bring this to you and get it going, and pay attention to it, keep it patched, keep it secure, right? Maybe you provide the hardware, that infrastructure, but slightly different, right? I hope that there's a future where maybe the next 5-year proposal and maybe direct some funding toward Pablo's team to, we ended you guys were here, we ended on kind of like, there's a little difference, I guess, in the projects. One is completely open source and kind of volunteer, and we arose out of the RCRV project with a mission to build a system that communicated between ship and shore and extended remote participation to shoreside users. That was written in our proposal. It's a deliverable for our project, right? So just to give you some of the, why are we different? How did we get here kind of background on the parameters measured slide. I don't know how I got there. Other things you can do, so just drilling down into the parameters. These are the kinds of information that we need. Standard names, control vocabularies we use, right? We keep in touch with R2R so that we're not building metadata that is going in a direction they're not going in. If you went to the MOM or the MFP talk, Noah calls it MOMs. We will coexist with MOMs. Like I'm here to tell you anything that we can do to. There was a conversation in the MOMs thing about how we duplication of inventory. We would we already can pull data out of MFP about your cruise plan, and that's going to give us, when you're going to want to leave, who your chief, a manifest of people. There's a lot of information there that we can pull in. Right now, we're just building up, a list of cruises, their identifiers, dates, where are they going. We can exploit that in our event logger, right? Yeah. So we have an interest to harvest a lot of that information out of MFP. Now for inventory, we would love to, if MFP is going to collect sensor inventory, that is great. I think what we need to do is identify what attributes they're tracking, what we're tracking. Okay, now we have a common set, and make a commitment to just make sure that those are maintained consistently in both places. Work out the details, but I'm committed to doing that so that Bonnie doesn't have to have too many. Did you put it too many relational databases in your life?
Yes.
I don't want that. A little example of what a sensor and event log is. This is not e-log. We kind of started fresh. But there's an interface where you can create events and sub-events. We're exploring a lot here with NOAA under the heading of operations logging. I just learned today that there's some C-log capabilities from OpenRVDAS to auto-generate log entries. I think that might be something we could do in reading logs. That's a really good. And a data visualization. As I mentioned, it used to be based on high charts and leaflet, still in leaflet, but we've totally redone the 2D, time series plotting. I think it's way better. I mean, now we have time slider widgets. You can go back, you can zoom in, and it's just kind of keeping up with the state of the art. Okay, system requirements. I told you that you need to, it's a distributed system. There are components in two places, right? So you need infrastructure on the ship and on the shore. There's this assumption that you have some kind of means of communicating with the shore. We used to be really concerned about how much bandwidth we're using, but with the bump in available bandwidth, I don't know how to characterize it, but with Starlink, we're a little bit less concerned, but we still only send the minimum amount we can home. We're going to send every observation. All your sensors are logging, if they're 1 hertz, 10 hertz, but we're not going to expand that into transform data and send that home. And we can do that transformation again on the shore. Maybe if we all agree that the bandwidth required to not do the second transformation on shore, maybe we can do it on the boat. It's in the noise. So you need 2 sites, you need 2 servers at each site. So you're gonna have a total of 4 servers. The specs are really, really hard to nail down because every boat's different. Particularly for processing, if we've got a boat that has 10 data feeds coming in, and they're pretty simple, 1 hertz data feeds, once a second, and then we've got another boat with 40 or 50, and some of them are really high velocity. You can imagine the processing kind of scaling function, right? So I'll just give you roughly a 6 CPU server with 8 gigs of RAM. Like that's going to actually do really well for OpenRVDAS, probably overkill. But the CORIOLIX server spec, because it's running that, it's got a relational database, it's got a web front end with data services running, it's requires more resources. And the ranges I picked from kind of what we've got deployed. So, you can see I've got a 1 CPU Raspberry Pi, but that system sits in a kind of like there's a mini version of the Scripps pier at Hatfield. It's got about 5 instruments, and that's what that Pi does really well. And then that's what the OpenRVDAS piece is. And then in the data center at OSU, I've got a little VM. It also looks like it has 1 CPU for the CORIOLIX piece because it really doesn't do a lot. There's it's only got 1 node, right? So it really depends on how big your operation is. So we'll work with you to kind of figure out what will work best for scaling, scaling your VM or for your shoreside system. Okay, so this is the fun part, I think. How much time do I have left now? 30 minutes, okay. Ship side to shore side, right? We've got our two environments, the distributed system. I want to walk you through how these things work together to kind of show, you know, so in this diagram here, we've got both CORIOLIX and OpenRVDAS, and we also have your sensors kind of up in the top left, and a component we haven't really talked about called the message broker on shore. But Pablo gave you, when he was talking about the cache data server and pub sub, he's essentially talking about a message queue. I mean, a kind of same publication. You can create a publication to the message broker. The message broker says, all right, I've got a publication, and it can take one or many subscribers. Pass that off to the subscribers. Okay, so here's what we're gonna do. Oh, there was an animation. I panicked. All right, so I'm gonna give you an example of a technician updating metadata, changing the logging configuration on the system. The technician, so here a new component has come up, our GUI. The technician could do this on the ship or the shore, but let's just say the technician is on the ship. So the ship tech, through the web interface, the one I showed you before, opens up a sensor, makes the change. Maybe they just toggled it on from disabled to enabled, okay? That attribute is written to the database and immediately synchronized to immediately works for this conversation. It's almost immediately is the actual truth. Goes to shore, right? But the point is it's consistent, right? We're not waiting along. We're not okay. When if you went to the MFP talk, you saw a mobile application that was going to sync, you know, when the next time it caught up, or maybe by push. That's kind of eventual consistency. This system is set up to immediately talk to its partner on shore. Okay, so that changes the configuration, right? Now, the system, you know, has just received an instruction that the login configuration has changed. So it needs to tell OpenRVDAS what to do. I had the ship shore tech, you know, make a change also. But so to deploy that configuration, that change we just made, maybe we made a lot of changes and just put 3 new instruments on there. The ship's tech opens the CORIOLIX GUI, goes to the system configuration page, and there's a button. We call it the big green button, the BGB. You depress the BGB. What that does is it signals OpenRVDAS that the configuration has changed. OpenRVDAS, a process on OpenRVDAS, calls the CORIOLIX API and it says, hey, what's changed? What do you want? Pulls that data information from the database. So it does like a GET request through the API, translates what comes back. Oh, you know, there used to be 13 directories, now there's 16, and here's how to set up those extra 3. Through a templating process, creates your OpenRVDAS cruise YAML file, that configuration file that tells OpenRVDAS what to do. Okay, and then you are now logging under a new configuration. Well, I glossed over that. There's one more, because we don't want to, it's a 2-step process. We actually require the user to kind of manually redo OpenRVDAS. I think that was just out of abundance of caution. We haven't yet made it fully on that, but there's nothing stopping that.
Chris, just real quick, will this happen to shore immediately as well? Once you API grab that database change, hit the green, will that translate to the shore side?
We don't do that.
Okay.
Yeah, you want to?
We don't do it, so we safeguard from someone doing it on shore, saying refresh and then suddenly the ship gets updated. So right now it's separate, but
Yeah,
we could set it up to be.
right now we
That's
push the
fine,
button in both places. Yeah. We're working through being part of the joy of like working with like Endeavor, PointServe, and now Savannah. It's like you have to be with your users to figure out all these different you can imagine a bunch of use cases, but you're not gonna get them all. So I think we want to take that feedback.
So the two instances diverge. If I had 3 sensors on board, what was Endeavor, and go through that big green button, blah, blah, blah.
They won't diverge because we've already synchronized the metadata.
You synchronize that pulling everything in through the API, so like.
Yeah.
Okay,
Yeah, the first step one is a user makes a change.
yeah,
That change propagates to the other side.
the other side, okay,
Nothing happens until that user then deploys that
right,
change.
and it's deployed on both.
Well, right now only on one.
Just on one.
We deploy on both sides.
Yeah,
And like Tristan was saying, our initial reason for that was protect against we have to develop the tooling to protect against the shore side user doing something that we don't want them to, or we just haven't yet. Okay, so that was kind of how does OpenRVDAS, how does CORIOLIX work with OpenRVDAS for changing the logging configuration? I'm going to show you how they do that. So that was like the abstract. How does this work? Here's how it works in the interface. The user goes to the front end, user logs in, right? So I'm already logged in, but that's how it works. You log in. If you're a technician, you have this privilege to go to your sensor page, go to a sensor. I'm gonna change the configuration of this MET station, so I want to edit its configuration. The sensor configuration form comes up, and in this case, what I was trying to illustrate was I checked enabled. So I enabled that sensor. Okay, I'm a step behind on my animation. You hit the submit button, that commits the change to the database and triggers the synchronization. So that's basically what it is. Like that was step one, and it wrote to the database, synchronized it to shore. So we're basically at that point where we're about to deploy now. Now the user goes back to the front end. Same thing, goes to system management this time. There's the big green button, refresh CORIOLIX. And what that's going to do, one of the things it's going to do is write an OpenRVDAS configuration file, but it's going to do it has a sequence of things to do. Create an OpenRVDAS configuration file, update any alerts that may have changed for persons that have subscribed to stuff based on that configuration change. Reconfigure RDAP to know, if a new data set is available. RDAP, our data server, needs to know about it. So it's got a lot of stuff to do. No, that was me. That's my animation. Sorry. Refresh CORIOLIX. So this was my example of step one. Okay. So big green button signals OpenRVDAS. How does that work? I showed you an API call. After you press the button, it calls the other system. It says, give me all of your instruments that are enabled, and makes an initial query. It gets a short list of instruments. This is JSON format, similar to YAML. Gets that complete set of enabled sensors, makes another query that's going to figure out what parameters are associated with that sensor. So it's going out and getting all the different things that you need to build what Pablo was showing, which is a logger. You need to know what the instrument is, how does it communicate, where do you want to write it, what parameters, how do you parse the message. Those are all the things that we manage inside of CORIOLIX to build your logging config so you don't have to. So that was just kind of an idea of, it's the only way I could think about visualizing like these API requests. But the series of API requests go out to find the information it needs to build a config file. Okay. I think I covered that. Now, data flows. Okay, so that was my attempt to show you how CORIOLIX and OpenRVDAS integrate around changing metadata, right? And remember, metadata is just how you want things, everything about what you want to have happen. That's synchronized, kept consistent between ship and shore. Okay, what we're going to show now is how data moves from your sensor. I show you 4 white boxes here. Those are sinks of data. That's where data doesn't go to die, just goes there maybe to reside for a little while. It's a sink. Okay. First thing I want to show you is there's a sequence of there's a structure to this, and that's what I'm trying to reveal here. Your sensor, say it's a thermosalinograph, takes a measurement. OpenRVDAS is configured to read that measurement off, say, a serial line. The first thing that happens is we are going to write that exactly as we copied it. Well, we're actually going to annotate it with two pieces of information. We're going to annotate it with the time that we got it in the sensor identifier, so we can always be sure of what we're looking at. But that's going to go to a raw file, and that's basically our collection of raw, unchanged. They annotated, in my mind, doesn't mean changed, improved, and that can go to R2R, right? Like that's your base unit, that's your raw data. Immediately after we write it, you can think of it as at the same time, we publish it. That's probably the right word. We publish it to a message broker under a topic, right? The topic is the boat and the instrument. The shore side, you have an identical OpenRVDAS instance on shore, and it's catching that, it's receiving that message and putting it in a raw file on shore. So at best, you are creating an identical copy of your data on shore. In reality, if you have dropouts in your satellite communications, you will leave a hole. There are ways to, if you have an operational requirement to not have holes in your data, we're working on a caching mechanism that can basically, Pablo already has a cache data server. We could probably leverage that. We're working on an architecture where there's a message broker on shore, because that's going to allow us to do really granular quality of service along pipeline. Okay, a little bit too much. The data goes to a file on both sides. Okay, the next thing I want to illustrate is the parsing and transforming. All of the information that we need to slice and dice, parse that message is embedded in that YAML file. It could be embedded. Pablo showed us how to do that. He also showed us how you can be a little smarter and put it in a device file. This is just our way of doing it. But so the first thing we're going to do is we're going to OpenRVDAS. We've given OpenRVDAS parsing instructions so it can execute them, right? So it's going to chop that message up into named variables. It might ignore some stuff if we don't need it, but the next thing it typically does is a transformation. Now, we don't embed all the information we need to do a transformation in the YAML file, because some transformations require data from an ancillary sensor or calibration coefficient, things that are not static. Let's just say that. So what it's going to do here in this case, it's got the basic information it needs. If there's an ancillary sensor, that's identified in the config file, so it knows where to look, and it's also stored in the CORIOLIX database. So it can query the API in real time for transformation coefficients, ancillary values from sensors to transform a voltage into like something that has a scientific unit, right? Then once so that's going to happen in parallel on ship and shore, because both of them received this like atomic smallest message they could. And it's the only reason we're doing that. Remember, bandwidth. We came from a world where we started this project, it was like 256, whatever bandwidth, and now we're up to megabytes, right? So maybe we can reevaluate that. But where we're at now, it's meant to be lightweight. This is like when you talk to the engineers, why are you doing this? You're doing it again. Like, why won't you listen? That we don't have a lot of bandwidth. So anyway, I've had that conversation like 50 times. I wanted to give you an example of that. So I queued up right now on this screen over here, I'm logged into the Savannah. Let's hope I'm still logged in. I'm not logged into Savannah. Get timed out. Of course. Well, if you will bear with me, I will do another one. View tab. Ah, you're kidding me. There we go. It doesn't take long. RVTEC, where we imagine the should see data. One TSG. All right, I'm in the data directory right now of the Savannah TSG. Now, let's take a look at this open file. TSG 11/11/04. That's today, right? Okay. This file is an example of what's getting written right here. So that terminal window is, I'm showing you writing to file on the boat, right? So there's the TSG message, there's the timestamp transform and the sensor ID transform. Looks like we have them in a different order than Pablo showed them, but not important. That's the write. Now I'll show you the receive, send to shore and receive. So what I've got here is just a free tool that can connect to my message broker. And I told you that each boat gets a topic, right? So here you can see Oceanus Endeavor. You can actually see like the last message I got from each of them. It's sad. Looks like right now Savannah and CORIOLIX are the only people at sea operating. Well, Ravel is operating, but we're in a standby on that. So if we pop up Savannah, you know, here are the messages that are arriving at shore. I noticed this morning on this that there's a couple seconds will go and it'll update. I think it's just the display up. You can see that things are updating. It's just I'm not sure. I don't think that we're actually missing data. We don't see that. That's the display isn't super fast. That's what I'm chalking it up to right now. But does that kind of trying to illustrate that's what I'd like to illustrate here is the first thing we talked about was database synchronization of metadata. That's a bi-directional, multi-master problem. This is data goes one way from the boat to shore. So we don't really call it replication. We don't really have anything else. It's just, I don't think of it as replication. It's not. But that trips people up. Okay, back to the presentation. Right. Data flow and parsing, part 2. Let me see if I can go back to slideshow. All right, so I just showed you kind of the part where the data made it to the first sync on the boat and the second sync on the shore. Now I kind of wanted to show you a little bit about parsing. Pablo mentioned that OpenRVDAS can parse with Python parse library with regex, whatever. I think we have our own regex library. I didn't know that maybe NIWA did the same thing. But what we're doing here is every instrument needs instructions on how to slice and dice up that message. And, you might have created your own particular sensor message. This can be a little bit painful, but I want to tell you that this really awesome thing that Jasmine did is she's got a GitHub repo for every instrument that we have ever come in contact with and how what the regular expression you could use to parse that. So this is a public resource, right? So it's one way to catalog, take the pressure off of you to create a regular expression. So we have a library of known working expressions. You may have to tweak, but generally really, really good thing. We also have a tool within, and if we have time, I'll show it to you. You can start with an example message that you've collected right out of one of your raw files. And with some basic instructions, you can start building your regex and testing it. And it'll, as you get it right along the way, it turns green and tells you where it went wrong. So there's tools inside of CORIOLIX to help you either build, debug, modify a regular expression, right? So it's like a place, it's a pain point, as Pablo mentioned, but it's something that's necessary for this to work. So this is kind of our way of trying to make it easy for you, is to not just give you a tool and ask you for regex. It's like, we'll ask you for regex, we're gonna help you build it, we're gonna help you test it, and we're also gonna keep a library of everything that ever worked. That's the idea. Okay, parsing. This was an example of, I don't know why what happened. This might be a different version, sorry, but this is test results of me trying to testing a cruise YAML, a regular expression parsing. Okay. I showed you the regex repo live already, so we took care of that slide. Okay, transforms. I told you we were going to do two things. So we talked about data and metadata, and we were also going to take a look at transforms. We leverage OpenRVDAS to do real-time data transformations, like real-time in the acquisition pipeline. We will provide the capability to do a transformation if you want to. I know that oftentimes I hear we just collect the data, we don't transform the data. I'd like to acknowledge that as like, you're only going to get so much gas mileage if that's the rule, right? So we're going to give you some capability to transform the data. I don't think it's controversial, but maybe it is. Okay, so here's an example of a transform that we're going to do with OpenRVDAS. So it's the sensor is TSG. Where's the rest? I think I lost a. Sorry, I think I lost a slide. Calibration transform. Okay, I think I'm missing a slide, but what I can tell you is we have a library. So inside of OpenRVDAS, when OpenRVDAS installs, it typically installs to opt OpenRVDAS. There's a local directory where you can make local changes. We have created our own transformation modules specific to run in CORIOLIX that are sensor specific. So we have another GitHub page of sensor transforms, and they basically plug in and become basically just to use one, you just have to add it to your YAML as a transform. But it knows the terms that when you did your parsing of data, we created named variables. So temperature and salinity, right, for TSG. The transform is looking for those terms, those variables, and maybe coefficients out of the API, and then it'll execute the mathematical transformation right at the point after. So we read it, we time-stamped it and added a prefix. We wrote it to a file. We parsed it with the regex transform. That's the pattern that we used, and then we called the calibration transform module for TSG here, and it pulled the right calibration coefficient out of the API and used the right equation to do the transform. So that's basically, we've arrived at the end of the integration piece. I would be happy to deep dive deeper into either of those or talk about something different, but I wanted to give Tristan a chance to. We're in the middle of we're right before a big update, so a lot of people that are used to using the system probably want to hear a little bit about how it's going to change. So if you haven't met Tristan yet, he's very cool, and yeah.
Thanks, Chris. So I'm gonna just.
There you go.
Thanks, Chris. Like everybody, Chris said, I'm Tristan. Nice to meet you all. I've met some of you online, but good to see you in person. I'm gonna run super quick through our update that's coming out. Hopefully this year is kind of what we're aiming for at this point. Just acknowledge that a lot of this is Jasmine's hard work, who is online with us. So big credit to her. The big major change bolded there is our back end updates. Our API and our data structures are changing. That's really the bulk of the update. Not super exciting visually, but it's gonna improve the experience pretty immensely, as well as speed things up is a big motivation there. We also are doing some plotting updates. There's a new plot at the bottom, just a new library, just overhaul there, licensing problems as well. So should also speed up. And then part of this, we're exploring some infrastructure changes and architecture around that replication that Chris was talking about. So can we have kind of a queue on ship so we don't get gaps on shore, and just, again, strengthening and hardening the process. So the big update is our data model change. So in red at the top is our old stuff. If you're a current user of CORIOLIX, you've probably seen our P1, P2 variable names that are hard to work with unless you spend time with us and we explain it to you. Down at the bottom is the new structure. So current, we organize around sensors. So we have one table for a sensor. There's a P1 for the parameter, a P2 for the next parameter, and so on and so forth. The new structure is parameter based. So one table per parameter. If you're measuring temperature, it's in the temperature table for that sensor. There's a couple of other small changes in there, like our flags are going to get a little simplified. So there's a summary flag. You can just pull the most relevant flag. Really just trying to be more descriptive. So our table names are no longer this weird mix of sensor mix large 11, which is convenient for us, but not great for anyone else. They're descriptive. They include the parameter name, they include the sensor ID, and they include the type of data. Is it full res? Is it bin? Similar story on our binned data. This is in JSON rather than a table, but our old data was, again, pretty nondescript. Bin data was in large groups. We've broken it down. It's going to be a lot more convenient to work with, is really the message there. We strip out some of the statistics that we present into a dedicated statistics table. A lot of people are telling us they don't use them, so we're just putting them somewhere else. They're not going away, but the message again is bin data should be easier to work with and faster to retrieve. Outside of that, similar story. So our data variable names are changing to be descriptive. We're changing away from NERC vocab. That's this part down here where it says ALAT SP01. A lot of our standard naming conventions for data tables were using that old NERC vocab. Not easy to read to anyone unless you do spend the time to look. We're trying to be human readable and use a CF standard. So rather than that weird ALAT, it's just latitude degrees, and then that builds into our data tables and structures. So on our API, those are going to be the source of truth for information, and our API endpoints are going to be latitude degrees rather than something nondescript. Outside of that, a big change that we're doing that's kind of behind the scenes is the way we're making tables and updates. So Chris was talking about that big green button press that coordinates the back and forth with RVDAS. This will build new tables for you. So we're going to try to streamline the process. So in our GUI, it's going to be type in your sensor metadata and do the updates you need to do a refresh, and then that will actually build the tables for you. So if you've added a new instrument, press your big green button. Now you have a table in our database that's pulled from that. So streamlining around storage, making it easier to access, but also for the technicians, just trying to streamline how many steps you need to do to keep stuff up to date. Right? It should just be a lot easier, and pulling some of that information down. Outside of that, there's some flavor stuff here and there. We're happy to talk about that in more detail. Things like primary parameter designations. If you have multiple sources for the same information, you can say, prefer this one, and then have kind of failover for if there's a secondary source. I think it's mostly a backend update, so I don't have any cool visuals to show you, this is what's changing. We're streamlining some of the interface. There's table stuff that has gone away, that's been deprecated. And like I said, I think we're pushing forward this year. We're working with people that are currently using it now to schedule when those updates are going to go out, but largely it's coming, and then we'll work with you to roll it out at a time that's convenient. The big note of caution is it will change our API. So I know on the Sequoia, they have these Grafana dashboards that they're pulling from our API. Our API endpoints will change, so just a word of caution, if you do have tools out there that you're using and pulling from our API, work with us and we'll help you kind of update that process. That was my super quick run through of that because we have 5 minutes, but that's our new update. Thank you.
Yeah. How we have time, right?
No, but 2 minutes.
Nailed it. No, I'm not going anywhere, so, would love to entertain questions at this, Pablo, do you wanna?
Questions, yeah.
Yeah. What did we do? What was unclear, anything you want, like, good luck, I'm gonna try to pick somebody non-OSU. Melissa,
Do you prefer a virtual environment for your servers for this, for your like Linux boxes? Or?
Yeah.
Just for this, you do prefer.
yeah, we don't really, in this, what I presented today, we don't really need like a hardware interface to anything, we're oftentimes we're receiving data UDP from another system upstream or something like that. So yeah, virtual is great. Definitely on the shore side. What we're seeing now is people moving their stuff. We were hosting Endeavor, we were hosting OSU, I'm hosting Point Surf. But for the other groups that aren't part of the RCRD project, I've been working with them, at least for the shore side, like Scripps has a data center, they got a virtualization cluster, they provisioned some VMs for me, great. At Skidaway, starting to work with UGA, there's some costs there as you get, but there's an on-campus virtualization environment. It's great. The only thing that's tough about virtualization, and we didn't cover it yesterday, as a developer, you walk into a new place like UGA and they're like, we do Alma or we do Red Hat. And you're like, well, we do W. And then you kind of look at each other and you're like, all right, we're doing Red Hat. So that's kind of uncomfortable. I don't like it because to me, it's fast backwards, like putting the pressure on the developer to like dump their stuff into security into the new thing, but that's the way it is. And so we're on Red Hat now and so we can kind of support either Red Hat, kind of variant stuff or Debian variant stuff. But it's just one of the quirks about, the more integrated and kind of enterprise you get, I'll start losing a little control.
Is there a Dockerized instance?
On Tristan's laptop, like the first thing he said when he got here is like, Docker guys.
Everyone has asked about OpenRVDAS on a on a Dockerized version. And I've kept saying, all right, we're volunteer. Somebody wants to Dockerize it. We're in. Nobody has done it yet.
RVTEC Dockerized, so there some of the components like I work with.
One more, so if a ship doesn't have shoreside virtual infrastructure, what do have you thought that, like, what you would suggest, what would they get? Like,
Yeah, oh yeah, so on ship we often get a physical system. I get one system, I put, KVM hypervisor, and I spin up my 2 machines that I need on one system, and that's the way we've been doing it from the beginning. And I've either work with you to buy a server to try to get you into something that has 2 power supplies, a track card and all that, because I think that's cool, but we can do it on commodity things too.
shoreside, you're like,
Yeah, doesn't matter.
you can't get into your like university's data center. How would you handle the action? Would you go like to?
I feel like you're
AWS?
driving me toward it, I might leverage surf it. Joseph.
Well, I have a question about that. Do you need a shore side? Could this just be locally hosted on your ship and you don't have to worry about it?
The reason to have a short side is to support shoreside users without having them touch the ship. So, yeah, if you don't have shoreside users, you don't need a shoreside. If you want to host it from your ship and you figure all that out to expose it, maybe there's a way to do that. And maybe that's smart.
Yeah, but there's a lot to be said for data presence. Is that the term you're still using?
Yes,
Or-
it's still all over our project execution
Okay.
plan, so yeah.
Yeah, just a
Jason, I'm on.
Jason, I'm fine.
Yeah.
Yeah. That's section of the day.
You got like skin on the movie. I can
That should go away. Okay.
All right. We can get started. I think I'm gonna ask you our folks to stand so we can get some participants. Please come. We've got open seats here. Be comfortable. We're gonna be here for an hour, so you might as well find yourself a nice spot. So my name is Karen Stocks. I'm part of the R2R group. To get started, if we could just have all the R2R folks stand up and just say your name and if you have a particular role in R2R. So, George.
Hi, everyone. I'm George. I'm the data manager on the SIO side. Also for UW and UAS.
I'm Gwen. I'm the data manager on the Vermont side. I'm Rebecca Kudak. I'm the lead PI for the Duluth side. I lead the R2R event logger. I specialize in control vocabulary. So if you want to talk that, please talk to me. We used to do the CTD QA, but we kind of shifted that to scripts and CCHDO.
Yeah, I'm Sean Smith. I lead the SAMOS project, which is real-time or near real-time meteorology and sonograph quality control, data distribution. I also am dealing with best practices. I work with Becca on some of the event log work, and we're going to be kicking off the air data working group. She'll hear about it.
I'm Amanda Lovett. I am with the SAMOS project, and I serve as the lead program.
Yeah, I'm Frank Nietzsche. I'm a lead PI from Lamont, and my background is geophysics. I will also tell a little bit of the geophysics data.
I'm Sam from Glee, and I work with the next.
Hi, my name is Ali. I'm from software collaborator from
Hi, I'm Drew Clark. I'm the technical director of R2R right now. And if you've been invited to see, I want to be there.
We do have some extras. Please make yourself comfortable.
I'm Alex, I'm the lead developer, the only developer for the website.
Did you miss anyone?
Well, we have five.
I'm the best ever.
Oh, I'm not sure if this is gonna work, but Lyle, are you able to unmute and say hello?
I have no clue if you can hear me, but I'm Lyle, and I'm the other data manager at Lamont.
So thank you all for coming today. You just met all of us and you can also find us with name tags. Before I get started, I have a few slides that just sort of give the big picture overview of R2R before we get into sort of data guidance and feedback and such. How many people feel like R2R, been there, done that? We know all about it. And how many feel like an overview would help? I'm not super familiar. And how many are just here enjoying their ice cream? Okay. Not a strong consensus in either direction. I'll give a real quick overview. Funded primarily by NSF with some other contributions. We've been going for about 15 years now. And we preserve and provide access to data from the US academic research fleet. It's all you guys. As I mentioned this morning, we collect the raw data, the data distributions from the vessels. We break that out. We put metadata around it. For some data types, we do some quality assessment, quality control. For some data types, we create standardized data products. We make all of that available from R2R, the website rvdata.us. We also then hand that off to the NOAA National Centers for Environmental Information for additional discovery and to flow into these global products, these aggregated products that get created from R2R as well as many other data sources. So this again is a summary of what we do in the R2R box. We also need to manage data releases. The chief scientist has up to 2 years that they can hold on to the data in most cases, and we have the cyber infrastructure that does all of this. If you look at it by the numbers, we've got data from about 45 vessels. Now this includes, we're 15 years, so this includes those that have been decommissioned over those years. We still support those data. Don't count too carefully on the in-service versus out-of-service ones. I need to adjust the slide. We've got data from about 35 different device types. We support both the human user and API or metadata API as access points. We do 8 quality assessments. We create 6 data products. SAMOS is the near real-time component. So everything else on R2R happens after the cruise. The distro gets handed off. SAMOS is getting, I believe, daily data from the vessels for just meteorology and surface water systems. And the event logger is the tool that you'll hear more about that Becca manages, that is out on the ships, keeping track of what's happening. We link data. Let me just see if I can make this go. We link to data held in other repositories that are from the same cruise that just helps people find data. We've got Bico Demo and GDS and multiple other places. And as mentioned, we submit to NCEI. I mentioned this morning, the numbers are pretty big here. We've got a lot of data coming through. 350 terabytes, single copy, 23 million downloadable files from getting close to 6,000 users. I mentioned SAMOS, the near real-time component for MET, TSG, and the event logger out at sea already. Here's a bit more about Samos. It's been going since 2005. It's not on all of your vessels, but it's on many vessels, and it's also on some non-US fleet vessels. It's used by a set of different kinds of users for different activities. Global coverage, but concentrated around North America. Further questions about that, Sean is here to help. All right, so that's the quickie overview of R2R. We'll now hand off to George and Gwyn to talk about some of our recommended data practices for you all. Then get into the event log harvesting project that Becca's leading, and the fair data, fair principles working group that Sean. Any questions on is and what it does as a high level? At a high level?
Yeah. George, thank you for being here. I know I'm the last item on your list today. So thanks for being here. Appreciate it. This is a good supplement to the R2R check-ins, which hopefully we've scheduled. I think we scheduled all of them. We're doing recommended data practices, which I don't want to feel like a list of more work for you guys to do. I think we want to go over and explain why we have these recommendations, and we think that they can help you, help us, help you, help the end user. So I don't want this to feel like more work. The purpose of this is not to give you a list of criteria where if you're missing an item, we send back your data package. It's not the goal. We want to, if there's any of these that you can't do for any reason, we want to open up dialogue and put that through. So next slide, please. All right. Maybe the biggest item on my section of this list. Every device that we break out meaning that we have data listed and associated to that device on our cruise catalog, has a device format document. These are what the end user has in order to kind of decode how to use that device, how to write a parser. The end user needs this in order to be able to make that file useful to them. And anybody that isn't the end user might see these different columns in the text files, and they might be able to read them. But to most users, that might be gibberish. And actually, Chris and Pablo were talking about all the different ways that data can be configured and everything. So those columns, the sample rates, the different standards that are being used in the data, that all should be explained. So the way that we do that is with these device format files. These usually take the form of text files that can also be PDFs. So the goal here is we want to kind of overhaul this. We want to work with you to have these text files as fully featured and as useful to the end users as possible. On the website, on our data submission page, we have two examples of kind of our vision for how these device format description details might look like. We're not going to go over that now, but we're happy to chat more with you on how that can look in a full featured way and really make the data maximally useful to the end users. Next slide, please. Okay, in order for any cruise, any data package, any distro, which is what we call the data packages, in order for that to be loaded into our system and made public to our users, we need to have some key pieces of information about the cruise. We call this cruise level metadata. The items are right here, stuff like the cruise ID and the chief scientist. We need to have all that on hand before. And the speediest way for us to get that is for us to parse that from the MFP API. So we have a whole pipeline just for that. And the simple thing is that if you're on the MFP, that makes us really happy. That makes this whole process extremely simple and straightforward. We acknowledge that there's probably a variety of reasons why maybe you can't be on the MFP or aren't right now. If that's the case, we would love to talk to you about how we can either standardize this cruise level metadata or work with you on getting you on the MFP. But this is really important to us, and speeding this up speeds every aspect of that cruise loading process. So MFP, great, thanks, Mike. All right, and we also touched on this last RVTEC, but one of the big bottlenecks that we have is really, really large data packages slowing down the network, taking a long time to transfer, and maybe introducing difficulties that small parts of that need to be adjusted. And one really easy way to get around that is we've noticed that certain vendors like the EK80 data will break 500 gigabytes. It'll go well into the terabyte range. And the easy way around that is we can work our pipeline on every other aspect of the data and every other data file if we separate out these EK80 files. So the request here is simply to have these big EK80 distro or have these big EK80 directories separated out from the rest of the folder as its own and staged and submitted to us as its own data package, so that we can pull over that smaller data package and work that through our system, and then maybe work through any issues or network bottlenecks with that EK80 separately. That will just make everything go faster. And we can start, if there's any issues with like the network slowing down or missing packets from those really large multi-terabyte network transfers, we can handle that independently of the rest of the suite of underway data. All right, one more. And maybe I should have cut down on the words here. There's really 2 points here. The first one, we make really good use of what we call an MD5 deep file. We say that a lot. MD5 deep is it's a manifest of every file that is in the data package, the distro, along with the checksum. So a cryptographic hash that details or that describes what that every byte of that amounts to in its totality. And the reason we use this is because this is our way to determine that every file that you saw on your side when you were packing up the distro is accounted for on our end after it goes to the network and after it goes through all of the different processing that might happen on your end. And we really care about the integrity of these files because any slight alteration could make it unusable for some reason. So we actually, for every cruise, we will look through this file and we'll calculate this MD5 file ourselves. We'll make sure that every single file that's in your copy of the MD5 appears in our copy. This is a big source of the emails that some of you might see from us saying that there's missing files or why is this directory not there. The way we're able to detect that much of the time is because we're checking these. So without these files, we wouldn't be able to do one of our first kind of baseline checks for the health of the distro. If you use OpenRVDAS, then this is actually being created automatically. You don't even need to worry about this. It's called MD5 summary.txt. You might see it in the top level. And then if you don't use OpenRVDAS, there's an easy workaround, and that would be to just generate this file yourself using a Linux command tool called MD5D. We're going to put an example command that you can run, a single line on the data submission. I think that would be really helpful. And you can just run that at the end and generate that file. It'll make us very happy if you get to have a really nice sanity check at the very end to know that everything is there. The other item is the file names of all the files is actually something that is pretty important to us because we look through each of those. We parse it and we don't look at every file manually, but we have scripts that will look at these file names and we will pull out features of them like the cruise ID and the dates, most commonly in that year, month, day format. So we will pull those out. We will compare them with the declared dates of the cruise distro from that cruise level metadata to make sure that we have the right data. We have the data that you claim is part of that cruise. That's kind of another big sanity check and is really useful for us. And those processes can get disrupted in other aspects of it, like our loading all of these into the database, can get disrupted if there are non-ASCII characters or single quotes, double quotes. We've seen some weird characters in file names. So the request here is that you remove any single quotes or characters that might trip up processing scripts for these files, and that you include dates when possible, like serial instruments. That gives us a really easy check to make sure that the dates that we have listed for that cruise match the bounds represented in the files. And please do include that MD5 if you're not using OpenRVDAS. Otherwise, you're good. Yes.
Specific for you on that. One data. I recently did a survey of all the vessels in the that data file names, and not one institution does it the same way. Not one. One instance. But it happens to be like as the final extension. There's dashes. There's not dashes. There's 2025s. There's just 25s.
Yeah.
All across.
It's a good observation. The biggest trip up is usually that if Julian Day format strings are being used, that kind of messes with our parsers, but I don't think we've run into an issue with maybe added dashes or removing a 20. That's not something that I've noticed, so I'm not too worried about that. But maybe in the future, Drew's not his head, maybe we will give you an email or something.
I just want to add that we recommend it because sometimes we get data from other cruises. So this is like a sanity check, like, yes, this is the right cruise. Yes, we have the right cruise dates. Well, maybe we don't have the right cruise dates. Let's go check, make sure we get it right in our database so everyone that comes back. And what this does is, like when you do your C2D QA, you take the dates that you think the cruise happens at, but sometimes we'll have that test from like 2 days before the cruise starts, and that will break that QA process. So this is really helpful. A lot of people don't do it, but we like them.
There's no official endorsement for ISO or national reviews or such. Yeah, that's awesome.
I guess we'll work through on a case by case basis.
With the T and the Z in
Yeah. Same. Or.
Z.
it?
That is. I think that's it for me.
All right, so forgive me if I'm looking down a lot. I have my notes on my phone. I couldn't find any note cards in all of San Diego. So, if you've talked to anyone at R2R before, I'm sure you've heard this ad nauseum. You're sick of it. But I'm going to repeat it one more time, and then also next year at RVTEC. But we want to receive data quarterly at least. You are always welcome to send us data more often than that, but at least quarterly is ideal. This gives us more time to validate our data that you send us, and as well, it also speeds up the data publication process, so we can get data out to people quicker. We also encourage all technicians to send us complete and finalized distros. We don't know what we don't know, and unless there's a glaring gap somewhere in a data set that we receive, we assume that everything that we get is complete. Once data goes through our process, it's difficult for us to make changes once we process the data. So if you notice that there's something wrong, something's missing, please reach out to us as soon as possible at info@rvdata.us before sending us anything new. Our preferred method of network transfer is Globus. It's great. It performs checks on all transmitted data to ensure file integrity. It ensures the security of the transfer, and probably best of all, it doesn't require a subscription to send anything to us. If you're pushing a large distro to us, please let us know beforehand. This gives us time to make sure that there's room for whatever you send us. If you're not currently using Globus, we're happy to help you get it set up. Feel free to talk to any of us wearing our little our name badges. Water column sonar data. Please confirm that it has navigation before sending it to us. NCEI requires that navigation be included in water column data. And if they don't get it, they come talk to us. We have to come talk to you. It becomes the whole thing. We don't want to bother you with something like that. So just leave it on all the time. That would be great. Gravity ties and magnetometer laybacks. I've been waiting to talk about gravity ties, I don't know, I think for like a month. So this is very exciting for me. Please include them in every single distro you send us. We don't care if it's an old gravity tie, if it's a new gravity tie. We want it every time. And we ask that you treat them as any other file you would send to R2R. So this means storing them in a consistent directory, ideally the docs directory, a high-level docs directory, and keeping a consistent naming structure. So we have an example, grav tie, _date, PDF, anything, as long as it's consistent. I'm going to skip down really quick. PFPE has a GitHub page with a lot of gravity tie information, a lot more general gravity tie information as well. So feel free to check that out if you have any questions. And this applies, my next point applies to anything ever that you send us at R2R. please, please, please do not send us anything that cannot be released, whether it be a private cruise, a military cruise, Navy cruise, Department of Defense cruise. If we can't release it, we don't really want it. We do our best to make sure that anything we release is supposed to be released. We send release emails out to chief scientists, but God forbid if wires get crossed somewhere, if we receive authorization for a cruise that we're not supposed to release, we can't release data that we don't have. So yeah, just don't send us anything we can't release. Yes.
Your gravity.
Yes.
So a lot of times we do land ties between cruises, so it doesn't belong to either. So if you want us to just say this belongs to this cruise and add it to it, because normally like our data is from, this is the cruise start, this is cruise end, there's 5 days in port, day 3, I'm doing a land tie. That's not gonna be in either of those cruises, so how do you want us to do that?
That's an excellent question.
So you should have like a calibration document file that doesn't change cruise by cruise. Like, do you have folder structures that have your instrument information? Because that would be a perfect place to put it, because it wouldn't, like, that gravity price wouldn't go to the next cruise unless you're going to a widely different place.
All right.
So you,
Yeah, the idea what Brent also said, if you have older ones, when you did the pod before, or even previous ones, collect them all in the same folder, dot folder with gravity tie, something, so there's no record of the past, like, when they get passed on, so it doesn't, well, these files are paid and not exactly from the group, but you want the,
Yeah, I think we can do put it in. If that had a form goes on the cruise that. Yeah, we don't have like a folder that I think full from, but.
Is this my slide?
This is our data submission page. This is where we have our kind of updated short list of, I guess, long list of these asks. We go into stuff like the data format, documentation, a little bit more detail, and anything that needs elucidation. Hopefully we have it in here. If not, please reach out. There's a QR code, but this page is best seen on the left. And recommended practice page is just a kind of one level up, going into the data submission page. There's some documents, things, flow through best practices, similar idea, same website.
do you have any questions, more questions for them before I start?
Yeah, if you want to, or if was broken, by the way.
No, you.
The one for the most issue.
It's set 404 on the first QR code.
It was.
Okay, I'm Rebecca Hudak, as I've mentioned before, I do a event logger with the R2R program. So for people who don't know, the R2R, one of the things that we had created is this at-sea event logger. In the past, it was this really old Dream plug. We've upgraded to these small Fitlet computers. We've worked with other ships to spin up VMs. We're open to do something like that. So the idea behind this is to be able to record events that happen during a cruise so that you know what is going on with the data if you try to use it 10 years from now. So 10 years from now, you might like open up a CTD file folder and you see, okay, you got consistent. What are all these messy things in the middle? And what these events can do is you can say, oh, we found out that this was plugged by some sea gunk and we cleaned it out, we flushed it really well, and now it's working again. Or there's something wrong with our sensor, we had to swap it out for a different sensor. Specifically with that kind of thing, sensor swaps will have different parameters and different calibration pages, so those are really important to know after the fact. This is an example. You start your cruise, your MET sensors are offering normal. Sometimes we'll get like your flow through system, if you're using your bow pump and for some reason you're on top of water and you move to your aft pump, we want to know because the intake of that water is different. And where you're picking it up might be different down the line. So it's all these small little things that can affect data. And it's helpful. I think it's helpful. We scientists would like to use it, but we also encourage technician events, calibration files. If you are calibrating your multi-beam, you can put in an attachment of your map of where you calibrated. Lots of things. I can go in great detail, but I'll move on. So we just got our next 5-year proposal. One of the things that we suggested that we wanted to do is to harvest the R2R vent logger. So what exactly does that mean? We wanted to be able to take the events that the event logger is capturing and be able to send it out to other groups that are monitoring the data, such as Sean's group at Samos. So Sean, if you don't know, he's going to talk a little later, but Samos will look at your map stations and they'll look at your weather sensors and tell you, hey, something's wrong with this. Is there a bird sitting on the sensor? You know, something like that, or they'll look at the data daily, I think, and they'll let you know if something's going on. So we want to be able to keep you from sending emails to Samos. So like right now, usually you send an email to Samos, hey, we swapped out a sensor. Please flag the data or change the calibration information. So this would take that step and make it automated. So instead of sending an email, you create a small event, an API goes sent to Sean, and he knows and it's notified, flags the data. I just kind of skipped over my points. Anyway, so we want to maintain up-to-date metadata, improve data flagging. So one of the things after this year, since we've had this proposal, is kind of our event logger is not quite at the right place yet to do this work. And we have a lot of questions. Do we create a sensor log that's built in on top of the e-log? And the reason we are thinking this, is that our current e-logger is cruise based, but sometimes you swap sensors when you're in port, or there's things that are happening in port that's not going to be captured cruise by cruise. So the idea temporarily is to have an overlying sensor log that could have a separate tab on your main page that would be just a continuous list of sensor events. So things that it would include, so it includes all our controlled vocabulary. I can talk about this for hours, but controlled vocabulary between different groups. If we're all talking the same language, we're all talking the same instruments, we're all talking the same parameters. And if you have issues with one type of model, you kind of know that already intrinsically, like you keep an idea of what's going on. So we'd use those, but the difference between this log and the regular event logger is it'd be more action specific for sensors. So your malfunctions, you're replacing it, you're repairing it, you're cleaning it, you're calibrating it. And included in that would be your serial numbers that are for those sensors. Right now, the event logger doesn't include serial numbers. The other thing Sean and I are doing is our controlled vocabulary is with the NERC BODC group. They do marine data controlled vocabulary. They do parameters, they do devices, they do generic devices. And what we're talking to them about is potentially creating like a location-based vocabulary. So is it on a MET mast? Is it on a forward mast? Is it on a port mast? Is it on your dog bridge? Is it on a wheelhouse? Is it on a monkey bridge? All these different locations are different on every ship. Everyone has different names for different things. You might have 4 different labs with different names. So it's a bit of a lift. And I think it's still important because once we know exactly the location you're talking about, will help understand like what that data is really looking at. So this is our data life cycle, right? You get a tech, he says the ship device, it doesn't work anymore. There's a malfunction, there's an error. So then this tech will go in the e-log, create an event saying, hey, this device, this serial number, this location is no longer working. So what happens is currently the HUI e-log, it calls back to shore every 5 minutes. It could be less, especially with higher bandwidth. And then at HUI, we would have a shoreside API that then would push to Samos, hey, there's a new event, this is what's happening. Samos would then be able to flag the data, and create a flag. Yeah, create a flag. And then we're at this point where, okay, now what? Do we have an end event? Do we have a sub event? How do we say that, okay, this malfunction is not happening anymore? So we're still kind of figuring it out. And what we would like is feedback from you guys. Like the last thing we want to do is create another thing for you to submit to. So brings me to my next point. We created a poll. Just tell us what sensor logs you guys are using now. Is it something we can currently incorporate? Is it something we can build off of? This would help us tremendously. Yeah, that's a lot of that. Yeah.
Just a general question, and this just might be me being blissfully unaware of things. Is this not stuff we could pull from CORIOLIX that in order to doing all this?
So from my understanding of CORIOLIX, there's processes not everyone is using. So some people are creating events, but not everyone's utilizing the event log or the sensor log. So theoretically, yes. And the ideal way, I think the real key is having an API, because once that happens, we can also communicate to CORIOLIX. If they create an event, it creates an event for us. And then that can also be sent to Sean or some other groups that might want to harvest this type of data.
So in the future, should I be using e-log at the same time?
I mean, I don't want to have you using more than one thing at a time. I think if it can be side by side and you choose to do one, but they communicate to each other, I think that would be okay. Because unless we end up harvesting the CORIOLIX e-log, the R2R e-log is the only one that travels with the data. So if scientists are looking at it, again, 10 years down the line, the R2R e-log currently is the only one they can see what's happening during the cruise. Okay. Yeah. Any other questions? All right. Sean, it's your turn. Okay.
So before I move on, the one I comment about what you were asking about with the e-log versus CORIOLIX log. First of all, CORIOLIX, my understanding, has both a science event log and a sensor log. There are two different parts to CORIOLIX. What I think we're trying to do, in part with this activity we're working on, is trying to standardize. All those logging systems need to be talking in the same language. They all have to use the same controlled vocabularies so that you can have a shoreside, basically, database of all the events and all the sensor events and everything, so that somebody like me and my group can write API calls to that to search for things that matter to us to affect the quality, flagging of the data. We really want to try to automate some of the quality control that we can get by getting information from those logs. And it's just, it's something we're starting to, we've been for the whole, probably last year, having meetings thinking about how does this actually work? How does it really work? And that's where that kind of flow diagram came up, because it was like, we're looking at, with the current event log, it's really easy to say when the event starts. But from a quality controls perspective, you got to know when it ends too. And we haven't figured out what those events look like, in any of the event logging systems that exist. So, this is where we need feedback, from you all about, what would this look like? How would you log that, something, not only that there was a problem, but that the problem was fixed? Both things need to be known to be able to be quality control.
I think one thing I really like about CORIOLIX is that logging, how we plan to use it is, I think a lot of times on like E-log, when we use E-log, we're putting in the time values. Sometimes it's different, what it's about, but, I just feel like the CORIOLIX, it's almost immediately when the problem is happening, it's reporting that, and stacking all of those things at the same time as well that we discussed earlier. So that's something I'd very much like to see in the future with, that there's going to be this separate E-log, application.
Okay, cool. Okay, so just a quick bit on a new initiative. This is a working group that we are organizing. I've been coming to RVTEC for 25 plus years. And one of the things this community has been very good about is when we have a task we want to do, we can get some people together from the data side, from the technician side, from the science side, and figure out a way we can actually move the community forward. And this is the idea behind this FAIR data working group. The first thing I'm just going to say, this is the general idea of what we're trying to do. The idea is to convene a working group to develop guidance for the fleet on how to align our data collection practices with the FAIR principles. So my first question, I'm going to say, show of hands, FAIR principles. Who's heard of them? About half. Okay, yeah, that's pretty good. So the FAIR principles, basically findable, accessible, interoperable, reusable. But what do they mean and what are they? Well, this is just some basic information on what we mean when we talk about the FAIR principles. When we talk about findability, it has to do with that data set being assigned some kind of persistent identifier, so you can always trace that individual data file or data set. So it can be cataloged and described with really rich metadata. One of the things we're going to see in a lot of these principles, metadata. It's all about having really, really good metadata to be able to make these principles work. Accessibility also focused on persistent metadata, and that the data are shared through free and open access protocols. So it's easy for people to find them, for computers to find them. That's a whole part of the accessibility. Interoperability. This is, to me, from my experience, probably one of the biggest challenges. Being able to take disparate data sets from all over, the different vessels in the fleet, recording data in different ways and different formats and all this, and trying to make them so that you can actually get different machines to go and grab that data and work with them together. This is a huge challenge. And again, it has to do with this idea of moving toward your digital resources so that there's standards in the way the data models are structured, data formats, uses of vocabularies. This is a big aspect of making the data interoperable. Again, you see metadata come up in this one. And then lastly, reusability, again, has to do with focusing on standards, community standards for how things are done and documented. So what does this mean for the academic fleet? I always think about that the FAIR principles, all those, Pirates of the Caribbean fans, they're more like guidelines than actual rules. The FAIR principles are really just somebody's concept of, what it means to make data fair. But getting from that to what you guys work on, which is practical application, what do I need to do? What's the actual thing I need to do to align my data with FAIR principles? That's the part that this working group is going to be focusing on. It's how do you go from principle to practical application? There's a lot of questions that come up. How should they be applied to the data we deal with? At what stage in the data life cycle should it be done? Should it be done at data collection? Should it be done at archival? Where in the pipeline should things happen? Who should be responsible for it? Is it the operator? Is it R2R? Is it the National Archive? Who is responsible for different aspects of making the data fair? Getting from principle to action takes a lot of time. I'm going to show, there are groups that have gone before us, that we are not the first people to try to do this. I'm going to show you an example here on the next slide. This is a working group that I contributed to, NASA OFAIR. This working group was for the NASA data centers. So there's about a dozen data centers around the United States for NASA, and they were trying to get their heads together about how do we, make the data sets in these 12 different data centers, fair. And you can see, I'm not going to ask you to read this. This was a 3-year process to get to this point, to go from fair principles to actionable things that the data centers could do, to actually align their data sets with these principles. Just as a quick example, they actually came up with a checklist, so they went from that grand diagram to a checklist of things people and data centers could do. And this is just an example of one of their checks, having to deal with the data being stored in standard open machine readable formats. Okay. And this is really all part of the interoperability requirement. So it focuses on interoperability. But one of the things you'll notice that I highlighted here, responsible party. This is a data producer issue. Those formats, the data needs to be put into those formats when it's actually produced, when it's actually created. There are other things in this checklist that are for the data centers. There's things that are for the data managers. There's things that are for the scientists. There's various different levels of who's responsible for what. So this is just an example of how this can be done. So the charge to the working group we're putting together, working group is going to have a 4-year lifetime through the end of our current 5-year NSF award. And we're going to start off by reviewing the existing implementation plans and procedures, something like OFAIR. There are other things that have been done in USGS. NOAA has stuff going on in this area. We'll look at what's being done. We're going to assess the readiness, the fair readiness of the data sets that academic fleet vessels collect using existing assessment tools. There are tools out there that we can actually apply to the data sets and say, how fair are they? And you'll get input into that. And then down the road in years, 2, 3, 4, we'll start looking at developing device-specific plans. The way to do this for a multi-beam is going to be different than how you do it for a meteorological system. You're going to have different, requirements for data formats, and everything is going to be slightly different for the different data sets. But really important is having the community come together and make the decisions on how to get there. So right now we're at the recruitment stage. So I'm up here saying, if you are interested in this work, we're looking for 3 or 4 marine technicians that want to be involved with this group. The group will actually have members from R2R. We're going to bring in data managers and archivists, and we're actually going to bring in people that are actual fair experts, people that this is what they do for a living. They're in the data science communities and have worked with FAIR for a long time. If you're interested in contributing, come find me, send me an email. We're going to try to formulate the working group in next month, and probably have our first meeting in probably December. That's probably the timeline for the first meeting. In terms of a commitment, this will probably be a once a month, Zoom, some type of virtual meeting. We will have an in-person meeting at every RVTEC, from here forward through the project. And one of the things I wanted to mention, it's on the bottom there. One of the challenges of doing this kind of work is a lot of it's been asked of us to do it pro bono. That's not the case here. We do have money to support honorariums for the members of this working group, the ones that can be paid, from federal funds. There are certain people I wouldn't be able to fund. But we do have some honorariums for the people that will be on this team, because this is going to actually take actual time. I mean, you have to be at the meetings. There's going to be work we need to do in between meetings if we're going to be doing like running assessment tools or whatever. So, this is going to be a time commitment that, will involve some actual, hours of your day. So at that point, oh, sorry, this is the last slide for R2R, so we'll come back to it. So questions about the FAIR group? Yeah, go ahead.
So does it fair just apply the data sets, or are you talking about the R2R workflow in a whole? So like even on the front end websites that are your data as well?
Well, FAIR is, it's a good question. I mean, FAIR really, I think of it as dealing with data myself, but, FAIR could be also, metadata, documentation. That's going to be one of the questions that this group could be looking at is what digital resources that we produce do you want to be out there in a way that they are, findable, accessible, interoperable, et cetera. And that's something that this community can look at. I was particularly looking at the digital data sets myself when we were thinking about this. I also didn't mention this, but in the FAIR community, if you ask anybody who's a FAIR expert, to almost 100%, they will say it's easier to make data fair if you look at it when you're collecting it. If you wait till it's been collected and handed to a national archive, it's much harder to make it fair because you have to go back down the data pipeline looking for all the metadata, the things that aren't there. So if you can do it a lot of it at data collection, it's a whole lot easier. Other questions? Oh, yeah, I didn't even know. Is there a chat on here? How do I see that? Anybody online got questions? Okay, cool. So Karen, do you want to take these? These are kind of the last overarching questions.
Okay.
And yes, I'll be here for the next 2 days. If you have interest, it said, please find me and we'll sign you up.
Okay, so we now have some time. When do we end? Is it past?
Yeah.
Okay, we got a few minutes. First, anything that you want to tell us, anything that you want R2R to hear about from your world that's on your mind, we get into questions that just you got specific questions, but yeah.
Yeah, so IT with Sequoia and speaking on large data sets and having had to chunk some of those larger file sets after then being on limited bandwidth or various location, to getting those reports that both us uploads have failed and we had to redo some of those. Just is there other strategies we can use? I come from our shoreside academic infrastructure where we have faster data types that are IT or different government links that are dedicated bandwidth. If we get the data set to shore, we're doing that through some systems, and we started front loading, sending a lot of our data earlier. But is there other strategies that you're exploring or that we would suggest to get the data sets as they're growing beyond quotas?
The one thing I can think of is, I talked about in the past, going straight to a cloud. The idea was we share our cloud provider. So we're basically putting it into a that would be ideal. But I would say almost our flexibility is global because it has the cloud. You can have a system transfer can stop for hours or days, and we pick right at that work. And so I think that's why it seemed to work well with shifts. I think the other unique issue at in Alaska, it's a bandwidth. Yeah, we're getting these changes. I know Julian is we basically said that's like this with that. So that's like stepping back in time. It's good for me. It worked. Yeah, it works.
we're trying to push transfers over that, and so anyway, we do that. But we do have a cloud provider we're working with, is the owners to that as well. Is lowest contract. Yeah.
How do you get the data off of that?
Oh, it's a good act?
Yeah, so once you get it off, then
Yeah.
you then get to a better.
So currently we have a couple of pathways.
Mhm.
We always generate a data disk. And if we know that we're not gonna have the bandwidth to send it, then we try to get somebody to sneaker net that data disk back to Fairbanks so that Kyle can then put it onto I2 and get it to you guys. It just might take quite some time to get it from wherever the ship is to a decent internet thing. We also have it set up so we can go from the ship directly to Globus, but bandwidth limited.
I mean, we asked for groups to try to get us data quarterly. So CORIOLIX has been above and beyond. So, if it takes a little while to get back to Fairbanks or whatever that may be.
Yeah, sure. One other option there. George is talking about the things separating this out. But it also works the other way around, that the Syria large data sets. You can transfer those to us separate. So you could send those from the ship straight to us, which is a lot from us data. Yeah. And then worry about the new data sets where you go back. Could be, a couple of weeks or months later. We now have that who's in our database. Really bad. A large data system. So it's an option to
That actually is what I wanted to bring up about what a challenge with R2R is knowing the status of have you received it, have you checksummed it. If there was some automated dashboard I could go to, I've tried. I was just corresponding with George about the API of your website. Yeah. If there was someone just yep, it's CORIOLIX. Okay, you haven't received, are you dated? All right, I gotta get on.
And we brought that up to you, I think it's really a good idea. And when we do verify approvals, if we just blast out that email to you, I thought that was a wonderful idea. Looking at very good.
Just a follow up on that, I think Gwen brought this up in her talk, is one of the problems or one of the challenges for our with that is we don't know what we don't know. We don't know what you're supposed to collect in a lot of cases. Now we do know we have your device list, so we know what devices are on the ship, but we don't necessarily know which ones were turned on to approve. So that's something else we'd have to work on to try to, maybe MFP can help with that. I don't know. But we need to know what you're collecting so that we can set up that kind of dashboard so you can check off what's there and what's something else we're talking about.
Yeah, I ask a question on that. Really, anybody can run that. Is that not what OpenVDM is supplying with a list of?
Yeah, OpenVDM generates that MD5D.
And that doesn't come over to RR at all?
It does.
Yeah, we use it.
Other thoughts on challenges or ways that we can help?
You guys mentioned that the APA files are too big. Software is handling it. Files for file size. So maybe if we have a better file size, it would work for you guys.
No, so George was submitting something. Really is. Some people let's on the house. Serious. But I don't really want to drive the resolution question. Right?
This doesn't change the resolution, just like the file, just starts a new file later. So each individual file will be sold. So each individual file will be easier. Next one.
It's just across the woods to put this on.
What we're surveying. So, for any of the EK frequencies, we can just say maximum file size 5 bytes.
All of the typical sizes for each set. I don't think it's really also configuration cases. That was the different.
So I think we are just about at time. I know we didn't get a lot of time for discussion, but we'll be around for the week. You just grab us with your thoughts. Maybe want to know how we can support you, what's working for you, what's not, and see how we can make it better. Thank you.